Think we are live. Welcome, everybody. My name is Andrew. We are joined here today by another Andrew. You may have seen him here on the channel before. Andrew Paris, Titan, is joining us today. And we're going to be covering the Orion Splashdown, which is expected at, I think, 12:39 p.m. Eastern Time, somewhere around there. So we're just going to wait for the NASA stream to start up here in about 10 minutes. In the meantime, we're just going to give you a quick overview of what's happening. But yeah, Titan, welcome. Thank you so much for coming back on the stream. And if you just want to give yourself a quick introduction and tell people what you got going on.
All right. Hi, Lambda. Thank you for having me. My name's Andrew Paris, call sign Titan. We are here today to watch the splashdown of the Orion 1 capsule for the Artemis 1 mission. My background is I worked for NASA for 13 years doing television. I did shuttle landings. I did operations at Johnson Space Center. I traveled all over the world for NASA. And left in 2000, and then recently, in the last couple of years, decided to get back into space, joined some friends of mine like Lambda and a bunch of others. We got our own group called the Inspired 24. We'll talk about that more later. But basically, we're all here to enjoy space and share the information we can.
Yeah, thank you very much. That's a great summary. So it should be pretty exciting. So far, Artemis has been a completely successful mission. SLS performed perfectly. Orion I think they added some test objectives during the mission because everything was going so well. But this is really a hugely important part of the splashdown. Obviously, the whole idea is that in the future, Orion will be carrying humans to the moon to orbit, and eventually they'll get down to the surface on some other vehicles. But we want to make sure that if humans are on board the spacecraft, that it can re-enter the atmosphere successfully and safely and get back down here on Earth. So yeah, NASA will be starting in about 8 minutes on the official broadcast, and we're going to commentate a little bit over what they're showing there on the stream. I'm going to take a couple minutes just to tweet something out. If I'm going to bring up a couple, let's see here, what should I bring up? Artemis 2 and Artemis 3 map. I'll bring up the video.
Well, before you do
ahead.
that, I just sent you on the Discord. I sent you two pictures. I like to get an understanding of where we were and where we are now. There's two pictures I just sent you there. There's the one from Apollo 8. If you could put that one up, and so we could see that, and we'll talk about what that's all about. Let's see, Absolutely. Where am I? There. Yeah, there we go. Yeah. So this is our return to the moon, Artemis. I don't know if a lot of people know this, but Artemis is Apollo's twin sister. So that's very poignant that they selected that name.
Yeah.
And I am of what NASA calls the Apollo generation. I grew up watching the Apollo missions and dreaming of becoming astronauts and so forth. Can you put up that first picture, that black and white?
Coming up in just a second.
Okay, I got to make that. Anyway, so I watched the Apollo 8 Christmas Eve broadcast from around the moon in 1968. I was 7 years old. And
wow.
For the longest time, once this picture comes up, is it up? I can't see the feed. Okay, you can see it's not that great of a picture. It's actually a live video stream, not stream. I can't even use that word. It was a broadcast from the not that one. That's the do you have the one that says live from Apollo 8?
Yeah, I think it's just a little bit delayed. It's up on the screen now.
Okay. All right, sorry. I'll just go with your cues. So anyway, you can see that was our first ever picture of the moon up close, and it wasn't all that good, but that's all we had. So we enjoyed it, and we liked it, and we embraced it. And then the other picture, that one, we've all seen the latest pictures from that have been come down, the 4K pictures coming down from Artemis. Is just amazing. It's kind of one of those where we've been and where we are now kind of things, and just to even see 4K video coming back at that quality and so forth is just amazing. And as a television engineer, I'm always striving for the best looking pictures you can, and so to know that they're doing that stuff. I actually talked to somebody yesterday. I gave a speech to the North Houston Space Society, and one of the people that was there yesterday was talking about he works on the systems, the solar panels and so forth. And I said, who was the genius who decided to put the GoPros out at the end of the at the end of the solar array. He says, well, it's something we always wanted to do. And I said, it was just pure genius. I mean, it's the perfect, you've got the perfect gimbal effect, or gimbal arm, like almost like a robot arm to give you the best pictures possible. And it gives them, they have the ability to do a complete 360-degree inspection of the vehicle, which from a safety and flight standards profile is fantastic.
Yeah.
So yeah, it's been amazing to see these pictures. It's a little sad we won't see anything like this for another couple of years, but
Yeah.
there's plenty of it to enjoy and to embrace and display for everybody.
No, absolutely. And you're completely right. It was such a mind-blowing thing to be getting live footage and pretty like fairly HD footage back from Orion for like almost the entire mission. If I understand correctly, I don't even think NASA thought they'd be able to do that. I think eventually they just they turned on a camera and figured out that they had enough bandwidth using the Deep Space Network, not only to get the data in the science videos back to Johnson and wherever else, but they also had additional bandwidth to just be able to upload would it be upload or download from orbit? I don't know, but
Technically, it's download.
yeah. So that's crazy. Like that like actually blew my mind that you can just watch an entire live feed, and I hope in a few years when there's this crew on board this capsule going to the moon, I hope we get the same type of footage and just be able to watch it go all the way out to the moon and back. It's absolutely outstanding.
Yeah, we're all used to with space. Early space shuttle was all ground stations, and they got the TDRS network up, and they got it really sophisticated. And so space station, we're all very used to having pretty much 100%, like in the 97, 98% coverage of all the time for the International Space Station. And a lot of that, believe it or not, has to do with the dish. They've got one dish that has to point, and at some point, as it's twisting around, it's got to stop and re-gimbal backwards. Otherwise, it's going to twist itself off and fall off the space station. So that's where you lose the 2%. But now, because we hadn't had any vehicles out in this deep space type environment, well, I shouldn't say deep space, but it's beyond low Earth orbit. Mm-hmm. They weren't sure what kind of receptions they're going to get with their ground stations and so forth. And so, yeah, so they aimed low to make sure that they weren't violating any rules or compromising the safety of the vehicle, so that they had plenty of time to do things. That's, in fact, the entire reason they did this distant retrograde orbit, was to give them time to fix things if things went wrong. Because if you did nothing, once it got into the middle part of the orbit, you could just leave it there and it keep going and going and going and going. So if you had issues, you could always take the time to upload new software or do whatever you want. They aren't going to have that opportunity the next time, but they wanted to make sure they got as much testing. And you're right, they added many more test objectives, which allowed them to really flesh out the vehicle. And I have to say, having worked at NASA for 13 years, you used the space shuttle hardware, which was pretty mature by the end of even by the late 90s, before I left NASA, was pretty mature. It was a pretty certain amount of reliability, but there was always some issues. To see a vehicle like this that's been on the drawing board for so long, not just the capsule and the service module, but the SLS, the upper stage, the interim cryogenic stage, to see it all work so perfectly gives me such a warm feeling to know that, hey, NASA does know what they're doing. Yeah, Absolutely. There may be some problems with contractors and delays and so forth, but overall, we have a very mature space program, and people should give those people credit. Because remember, this isn't some robots doing this. These are human beings creating these rockets, and they're trying their best. They're doing their best, and we're trying to build upon what we learned from previous. And that's the great thing about it, is we haven't forgotten everything, because when we transitioned from the Saturn V, from the Apollo missions, basically they just threw all that gear away, and then we had to start over again with the shuttle. Right. Well, this transition's been a little cleaner because they've reused a lot of the hardware. The engines were reused, the SRBs were reused, and essentially the tank was modified. The external tank became a real stage. So, and there are people from the shuttle program who are still part of it. So you have a lot of that institutional knowledge that's been carried through, which is always very important to avoid things like go fever.
Yeah.
I've talked about that before. So yeah, it's amazing. I love being surprised. I love seeing all these things go well. It's fantastic.
Yeah, and I think it was kind of a moment of reflection for a lot of people that have just kind of started to get into the whole space stuff in the last few years. A lot of people are used to seeing what SpaceX is doing with the Starship, with iterative testing and blowing things up, and a lot of the new launch providers that unfortunately have been failing. Sorry, one moment. The stream is starting, so let me mute it while we're talking.
Okay.
But this just went to show that, NASA's strategy about build it once and build it right, is still a valid option. There's different ways to do things, and theirs is just as valid as it's ever been. It launched for the first time with not a single issue. Of course, there was some issues like actually getting it up off the pad with hydrogen leaks and stuff,
Oh yeah.
but it's just like amazing. It was just a mind blowing experience to just see it launch and it just have it work perfectly.
Oh yeah, yeah. I was gonna after a couple of other teammates, Risk and Chef were down there for the launch. We were very fortunate to be able to go down and watch it. And I was telling people I'm gonna have a grinectomy because
Yeah,
I just couldn't stop smiling. It was amazing. Do you have that video we can show? Maybe we can show the launch video.
absolutely.
Yeah, so I happened to be working in Jacksonville, north of Jacksonville, when they finally set the date. So I was able to get off work at 4 o'clock. A buddy of mine, we drove down, got there in time to get on the bus, go out to Banana Creek, watch the launch at about 1:45 in the morning or whatever it was, and get back in the car and drive back and go to work. So I didn't get any sleep that night, but it was worth it. I was so pumped up. It was amazing.
The video is playing now. It's such
All right,
you
so
got such a good perspective of everybody here.
yeah. So I can't see it yet, but I'll tell you from what I remember. It's night becomes day, and then the sound hits. I don't know if you've got the sound up, but it was amazing. The pressure. I had witnessed a couple shuttle launches, and it would always impress me about the acoustical beating on the chest. Well, this was 25% louder and more powerful. 8.8 million pounds of thrust. So it really did hit. And what was amazing is after a few seconds of the sound hitting us, all of a sudden we heard this almost like frog chirping noise behind us, and it was the building that their Saturn V is there at Kennedy Space Center. The sheet metal inside of it looked vibrating in a specific rate.
That's insane.
And it was like, if you ever can get out, I mean, SLS launches are going to be pretty rare. I count myself so fortunate to have made the first one, and hopefully now I can keep the record going. So, it was amazing. And now I have a sense of what the Saturn V was like. My experience has always been just shuttle. But now, it was, I can't wait to see it again. And a couple more years, but we'll wait and see.
Absolutely. I'm gonna slowly start fading in the audio from the Artemis stream. Do you have it up on your side as well?
No, I have that muted.
Okay, gotcha. They're starting the video now.
Okay.
Looks like a cool introduction here from Apollo footage.
Stop push. Engine stop. Engine arm. Proceed. Command override off. Boat control ahead. Hold. Pings auto. Okay, Houston, the Challenger has landed. Houston, you can tell America that Challenger is at Taurus Littrow.
What a cool way to start this stream with Apollo footage.
Yeah.
50 years ago today,
actually, I have NASA
17
TV
Commander Gene Cernan and Lunar Module pilot Jack Schmidt guided Challenger to a pinpoint landing on the barren rock-strewn area of the moon called Taurus Littrow. A half-century later, moon explorer, the Orion spacecraft.
We're getting live views from the Mission Control Center here, and it looks like they still got a live view right in the center there of Mission Control, showing Earth quickly coming into view for Orion.
Down in the Pacific Ocean,
so they're just what,
Baja California,
an hour?
Shakedown mission.
How far? Just a little over an hour away.
Exploration.
Yep.
Good morning from the Artemis Flight Control Room here at the Johnson Space Center in Houston and Mission Control, where the entry team of flight controllers is on duty, ready to bring Orion home to complete a 25-and-a-half-day mission. As he was for the launch of Orion more than 25 days ago, NASA Flight Director Judd Freeling is leading the entry team here in the White Flight Control Room. The target for Orion is growing larger in the field of view, moment by moment. This is a live view of the Earth from a distance of 15,000 miles away. About 3 hours and 40 minutes ago, Orion conducted the final major maneuver of its mission. A return.
What a beautiful shot. That is insane.
Yeah.
The crescent Earth.
Yeah, that's amazing.
It's actually a really nice shot as well, because you kind of see the aft side of Orion and the thruster it was using for all of its orbital maneuvers. It used how many do I might have to look it up. Do you know on top of your head how many firings there was over the course of the mission? Because I don't know if it's been officially published yet because they've had to do a bunch of correction maneuvers.
Yeah, no, they hadn't published that, but I'm sure they will eventually. But it was quite a bit. They like to fine tune, especially coming in for a water landing. They want to fine tune the final position because they want the recovery teams to be as close as possible. It's actually very, SpaceX does it with their Dragon. They can pretty much pinpoint it off either the east or the west coast of Florida. But they're coming in. Oh, wow, that's animation. It looked like the real thing for a second.
It's a great animation.
My mind how good. Yeah, it's great animation. Yeah,
that's you bring up a great point actually just about splashdown. I think it would be cool to mention real quick that originally they were planning on splashing off the coast of San Diego. However, because of some of the weather concerns that are going out in San Diego now, I believe that they moved the recovery point a bit further south, actually off of the coast of Baja California.
Yes, exactly. That was part of they had always had multiple locations to land. That's their primary, was always as close to land as possible to the facilities, but that doesn't really change, the ability for them to pinpoint it. They'll want to get it. They'll keep the recovery vehicles at a certain distance and then aim for that point.
Yeah.
Interestingly enough, they're talking about it right here about the way they're coming in. I wonder if they'll talk about the skip. I don't think they're going to talk about the skip.
Yeah.
Yeah. They're back in the Apollo days when they came in. They were coming in from the moon at about 25,000 miles an hour, and they had to burn off all that energy coming straight in, and then they had theorized about the ability of dipping down in the atmosphere and then coming back up, and then allow them for more control. Once they burn that energy up, they could be in more control and then pick a place. They ended up not doing it, even though the process was in place and they rehearsed it. That they never used it because they were concerned about crew safety, getting all those G's and then back up and then more G's. But since they have no crew aboard here, they're going to try that this time. They're actually going to dip down the atmosphere and then using the geometry of the spacecraft, rotate it around and create lift and then lift it back up, and then they can kind of be over there, better fine tune it, and then they can use it to come back down.
Very cool. It's such an interesting theory because I was always taught that one of the interesting parts about coming back into Earth atmosphere is that if you're too slow, you can actually bounce off the atmosphere and it wouldn't be good. I didn't realize that there was actually a nominal case to use that feature, that functionality to bring crew back home in a capsule or something. And I actually did see that on Apollo 8. There was a skip. It's not officially considered a skip maneuver because it didn't come back out from the atmosphere, but it gained I think it was 5,000 or 10,000 feet. There was some sort of skip with Apollo 8, but I guess it just wasn't far enough out for it actually to be considered an official skip maneuver. But yeah, it's cool.
I believe this to qualify as a full skip is you come back out of the atmosphere and you're not experiencing the G forces, so you're basically resetting and then coming back down. And the maneuvering, I mean, it was all, you remember Apollo, as I tell people when I'm showing it, I'm giving tours at Space Center Houston with the Saturn V, that all was designed and built before computers. I mean, computers back then were people. So we didn't have computers to do a lot of the simulations. So a lot of it was, it was the pilots, the astronauts using their piloting skills and being able to adjust the spacecraft to a certain way. And so a lot of things may have happened because they, on accident, but they survived it. So yeah.
Yep. Wow, this is exciting. It's crazy to see that this mission is coming together. So they officially got it off the ground on the 16th of November, right?
Yes. Officially the third try.
Yeah, and I feel like it's been this mission. I feel like it's been going on for months, and I know it's been almost a month, but I feel like it's been going on for such a long time. And just the fact that this thing's coming back today is really exciting.
Yeah, it's definitely longer than I remember any shuttle mission going. Then the shuttle missions were 2 weeks was the normal shuttle mission.
Yep.
So getting used to that, I had to keep reminding myself, hey, we have a vehicle out in space and we've got to worry about it getting it back and so forth. But but it's been really great being able to tell people, explain to people. And that's actually one of the things I was going to tell you about was you had, people, because they see this, the way SpaceX does their development, build it, fly it, blow it up, build it, fly it, blow it up. They just assume, some people just assume that's how you did it. And they watch NASA and they don't see NASA doing it, going, what are they
Right.
doing wrong?
Right.
Or in the case of what they don't, there are a lot of people aren't alive to remember the success of the space shuttle program. I mean, it was expensive and so forth, and we did have some accidents and so forth, but it was a pretty as vehicles go, there was routine was we're going to get it.
Right.
And so they haven't seen NASA fly any manned vehicles in 11 years.
Yeah. I mean,
so telling people, no, NASA knows what they're doing. Like I said, you may have some problems with some contractors, but NASA does know how to put things into space, and it's just great to watch them do it. And it's funny watching the recovery team here. When I was a kid watching the Apollo or the splashdowns, that was all really early technology. So they were doing microwaves from ship to ship, and then one ship would have a satellite dish, and it wasn't really good auto tracking. So if you got pictures from the live pictures from the aircraft carriers and stuff, that was pretty amazing. But they'd also use an entire task force. They'd have multiple ships. So it was like, it was nothing but ships around. Now it's essentially, I think, 3 ships is what I heard. And because everything is so much well coordinated, and they know they're not going to have to worry about vehicles landing hundreds of miles away, which would happen to some of the early Gemini missions, because of one reason or another. They landed so far away that the astronauts are basically on their own for hours.
Yeah, crazy stuff. And these views from the ship is absolutely amazing. I love the fact that we're getting these views, and I hope that when they're actually recovering Orion, they're going to show all these cameras, or if it's going to be one of those things.
Yeah, absolutely.
That would be so cool. Man, they've stepped up their game a little bit. I wasn't expecting all these views from the ships and everything. And this looks like it'll be a top-down view of where the capsule is going to sit after they bring it up on board. That's awesome.
Yep. You have to remember one thing about television for NASA, something I learned very early when I went there. The television cameras and stuff that the shuttle program was using, and eventually International Space Station, wasn't really for PAO. It was for engineering. They want to see what's going on.
Exactly.
PAO is always kind of a hanger-on. But they've learned the value of the value of letting people know what's going on. I mean, the modern world, social media, got to show everybody's live streams. And I'd be willing to bet a case of beer that they're using Starlink for this. What do you think?
They might be. Let's try to keep our eyes out and see if we see a dish anywhere. I'm gonna take a quick moment I know some people have been trickling in, so I just want to do one more quick introduction about what we're seeing here. So thanks everybody for hanging out here. My name is Andrew. This is Rocket Future. I'm joined here today by another Andrew Titan Paris, and we're here to tell you about Orion's return to Earth after its journey out to the moon as a part of the Artemis 1 mission. If you're hanging out in chat, let me know where you're watching from. Let me know what you're most excited to see today. Give us a 5x5 if the audio is good. If you have any feedback on and how the stream is looking, let us know. But just let us know you're here and watching us. That's about it. Titan, do you have anything to say?
Excited like you. Just it's a little rainy day here, so it's good to be indoors and be on a live stream, waiting for this to happen. Like I said, when I was a kid watching this stuff, we were watching Walter Cronkite on CBS, and if we got a few minutes of live video from the aircraft carrier, we were very impressed. But yeah, getting a couple of times you got to actually see the Apollo spacecraft hit the water. So it was very exciting as a kid. In fact, if I remember correctly, I got to watch one of the landings, splashdowns in school. They stopped school, rolled a TV in, put up the old rabbit ears and tinfoil, and got it working.
That's awesome. We have Treefinger6 that says good morning. Good morning, Tree. Mike, thanks for joining. He says, great interview, Andrews. Sounding and looking great. And Ben is saying he's also greeting Mike's. So thanks, everybody, for hanging out. Wow.
Yeah, thank you for joining us. Oh, I closed the window. Hold on a second. Close my window here.
They just changed it. But beautiful shot.
Okay.
Oh, so, yeah. It sounds like they're going to talk a little bit about the launch of Artemis 1 here. So of course
Okay.
there's 4 RS-25 main engines on SLS, 2 solid rocket boosters. It's similar solid rocket boosters to what was used in the shuttle, except they're 2 sections longer. I think two sections longer or 1 section longer.
But it's one segment. It's a 5 segment, not a 4 segment.
Right. And that makes up the core stage. I think officially when it launched, it was the most powerful rocket to make it to deploy payload into orbit. That one little caveat is I believe N1 is actually technically more powerful, but it never successfully was able to deploy anything.
Yes, that's correct. It does. Yeah, it theoretically had more power, but because it never successfully achieved orbit or put its payload in orbit, like you were saying, it doesn't count. And the shuttle was about 7.8, if I remember correctly. But the Saturn V, and this is one of those historical moments. One of the things, for years I've been doing the tours at Space Center Houston at the rocket park, and I get to say, here's our Saturn V rocket, the biggest and most powerful rocket to ever fly. Well, I don't get to say that anymore. I say, well, it's the biggest, but it's not the most powerful. And then, of course, with Super Heavy, a matter of minutes from now, weeks, minutes, months, years, will launch. And of course, it's going to blow everybody away with about, I keep seeing different numbers. I don't know what you've heard. Is it 17 million, 17.5 million, 18 million pounds?
Something around there. I'd have to check the most recent update on it, but you pretty much hit it on the head there. It keeps changing. And the best part about that is no longer will you have to say anything caveats about N1. It'll just be, when it launches, it just will be the largest, most powerful rocket ever, period, which is a nice, clean way to say it.
Yeah, absolutely. Yeah, it's a fun, like I said, I keep saying it's a fun time to be alive.
Yep.
And talking space.
Yep.
So
Tree Fingers is asking what time Splash is. I think we're expecting it to be right around 12:40 Eastern time. I believe that's the most.
I'm going to see. I'm going to bring up and see if I can find out what the Artemis 1 landing time. They may be adjusting. Yeah, right. It's still technically 12:40 p.m. Eastern, so it'll be 11:40 time. Yeah, so a little over an hour and 20 minutes or so from now, 24 minutes. And yeah, I'm hoping they keep that live stream of video coming down from from Artemis and the Orion capsule. And by the way, a lot of the NASA's getting a lot of credit for the capsule and all the hardware, but ESA, European Space Agency, should get a lot of credit for their service module. A lot of people don't know that that's based on the Columbus cargo module that took cargo to the International Space Station. They used that base design, the propulsion module, and modified it slightly. So that's part of their contributions to this effort. So that's why European astronauts will be flying on the Artemis missions also. But I've always wondered, I need to talk to somebody who was part of the design. You know, we're used to seeing the Apollo service and command module the capsule went down and it was a straight cylinder. Well, Artemis has that much smaller service module. It looks kind of like somebody wasn't measuring correctly. One was using metric and one was using standard or whatever like that. And but obviously that was the best way to do it. So that's what they did it.
Yep. I'm gonna get a countdown timer up here on the stream.
Okay.
And is this a live shot that we're seeing from Orion right now? You can see the Terminator between day and night, which is absolutely just so cool to see.
Yeah.
1 hour and 21 minutes. That sound about right?
Okay. Yeah. Another piece of interesting fact about this service module, it uses the main engine for it is actually an OMS engine that was used originally on the space shuttle. So once again, they're not only recycling the RS-25 engines and the SRBs, but they're recycling the OMS engines too.
Right. So am I correct in saying that actual physical engine was used? Like, not only is it the same type of engine, but they actually took that off of a shuttle that was used and put it
correct.
On Orion, right?
Yeah.
That's cool.
So they had 3 pairs of OMS engines at the end of the program, so that's 6 engines. Now they have, of course, taken them and done some upgrades to them because the technology changes and computers. I think they put, just like the RS-25s when they were called the Space Shuttle SSMEs, the Space Shuttle main engines, and the transfer to make them RS-25s, they changed out the the controller boxes. They went to a new, more solid state and new software and so forth. And they actually were able to increase the efficiency. I forget what the last percentage, because that's something that's was weird about the space shuttle program. And they talk about the engines on the space shuttle, and they talk about they're going to fly at 109% of rated thrust. And you're like, how can something thrust more than 100%? Well, they based that number on the original design, theoretical designs from the baseline from the late 70s. And when they found ways to make it more efficient, they, rather than rewrite the scale, they just tacked it on the back of it. I want to say, I thought the RS-25s are like at 113%. So there's that's 13% efficiency increase. That's pretty amazing.
Yep.
For a rocket engine.
Especially considering all the engineering time that went into it for like the beginning of the shuttle, like the fact that you can still get another X amount of percent out of it is just absolutely insane. You can, I wonder how many like hours people have put into engineering RS-25s.
Hundreds of thousands.
Yeah.
And so one thing about the RS-25s, they're reusing the space shuttle ones, the legacy as they call them, engines that have all flown before. They are going to build new ones because they're going to run out of used ones. And those, I believe, RS-25s are going to be the C or D versions, and they'll actually go higher than 113%. They may be as high as 115, 117%. That's because they're building from scratch now, so they're able to do some 3D printing, and they're being able to do upgrades, because all us engineers, we love to fix things. We like to upgrade things, we like to improve things. So that's what they're doing, and more power to them.
Absolutely. Brandon Higby says, "Where is landing? Can we take the boat there? I want to surf the space landing wave. Way cooler than a tidal wave or barge wave." It won't
be much of a splash.
Yeah, it should be pretty low key of a landing. Under those parachutes, it'll come down pretty low. But it would be cool to be out there and see it. Granted, I'm sure they got the area secured down pretty tight. But
yeah, I'm hoping they don't have the same problem they had with what was it, Bob and Doug?
Yeah,
when they came home on OFT 2.
Yeah.
Demo 2. Yeah. Oh my goodness. I was so. I'm like, what are you people doing? Get away from that thing. It's going to kill you.
Yeah. So for anybody that didn't catch what had happened there, I do believe it was Demo 2, which was the first crewed Dragon mission, which was the first crewed launch from U.S. soil in how many years was it since the last shuttle launch?
Technically, yes.
And so when the capsule came back down and landed off, I think it was east coast of Florida, I believe. Unfortunately, a lot of just like random people in their boats kind of approached the capsule, which first of all, it's kind of just, I mean, obviously it's very disrespectful to it's obviously needs to be a secure situation, but also you're putting yourself at risk if you're going to go out and do something like that. There's some dangerous stuff involved with those capsules, and the NASA astronauts and everybody, they know the risks and they've been trained on the risks and what to do if something happens. But these random people around there, they're putting themselves in more risk than they know.
Yeah, exactly. They were completely unaware of the dangers of the bipropellants they use on the orbiter. They use essentially the same maneuvering thrusters, RCS thrusters, as the shuttle did. It's basically two chemicals that are stored for a long time. When they touch, they ignite, and that way you don't have to have any sophisticated electronics or mechanics to use the thrusters. Makes them very reliable. But unfortunately, they're very toxic. And I don't know if anybody remembers the shuttle landings. Once the shuttle landed, they didn't get out right away. They spent better part of an hour to 2 hours of cruise in their cruise in. Oh, my son-in-law's calling. They spent a lot of time with people in escape suits, essentially were not pressure suits, but like oxygen masks, going around sniffing. They had long poles. They would sniff the thrusters to see if anything had leaked, because they close all the valves, and that's supposed to be it. But sometimes there were leaks. And in fact, part of my duties when I was working on the part of the convoy with the shuttle was we had to go through respirator training. And because if something was to start leaking, there'd be all kinds of alarms. You'd put your respirator on and then move upwind and so forth like that. And so, yeah, people don't realize how dangerous stuff is. But the recovery crews were all very well trained in that, and they have procedures for doing that. As we've seen, both Dragon and the Starliner landings, they have their process where they're doing that stuff. And once they safe the vehicle, even after the vehicle is technically safe, it's still considered hazardous. So it's limited access.
Yeah, I have one more note on that, but before I go into that note, we got a question from Tree Fingers asking what is landing speed. I just quickly double checked here, and based on what I can see, it sounds like just by coming back down through the atmosphere, it's gonna slow it down below 500 miles per hour, and then the chutes will come out, and then it's gonna be under 20 miles per hour before it actually splashes down. So
Yeah,
I'm surprised
I
by that
think.
fact. If that's true, if the atmosphere just like really brings the speed down to like 300 miles per hour, that's crazy.
Yeah, that's burning off quite a bit of energy. The Apollo missions were coming in at about I remember it was like 25,000 miles an hour, and I believe this is even going even faster because they're coming from farther out in space. And one of the things about the Apollo missions, they all stayed on essentially a equatorial orbit. It was, if you look at the
Mm,
pictures, it's a figure eight, but essentially they go out and they would go around the moon at the equator. When they come back, they would come back, and of course they would uh, when they were firing their surface propulsion system engine to come home, they would fire just strong enough to get to the point where the Earth and Moon's gravity equaled out, and they would just pop over that, and then they would actually become very slow down to only a few feet per second, and then
right,
Earth's gravity would grab a hold of them and then take them down. And they did that to keep the speed down as low as possible. Well, they don't have this option because the moon's gravity is long gone. They're coming in out of deep space, and
right,
so this is the worst case scenario that they wanted to have to test the speed of the check the quality of the heat shield
right.
on the Orion capsule.
Yep, yep. They've done a lot of research on the heat shield, and they obviously we talked about EFT1. They tested the heat shield, and
Mm-hmm.
I'm really curious to see what data will come back from today's test to see what they say.
Yeah.
Uh, to rewind just a quick moment, just kind of about those dangerous fuels and stuff that exist with these spacecrafts. I believe I believe it was during a stream, and Titan, you might have been streaming with me. Was it the return of the last Starliner mission or something? I remember they were going to safe the vehicle, and then they detected some of those dangerous
That's right.
fumes, and they had to step back. And it just kind of shows, these people go out there with these equipment, and it tells them whether or not the area around that is safe, and they were in the bunny suits and everything to make sure they're safe. But yeah, they were approaching the vehicle and actually had to move back because they detected too high levels of hydrazine or whatever it was. I forget.
Probably hydrazine. Yeah.
Yeah.
I can't keep the technical terms for those fuels is a mouthful, and I can't. I mean, like I said, I was trained on it in the 80s, and but I do remember one of the instructors one time and said basically we said, well, how do we know if this stuff is really says, well, if you smell fish, you're dead.
Yeah. Yeah.
Like, ooh, who figured that out?
Yep. Yeah. Yeah. It's scary stuff for sure. Scary stuff for
Yeah.
sure. Oh man, we got just under an hour and 15 minutes. So we should start to get to see some excitement here happening soon. So
Yeah.
basically, yeah, what we expect to see is eventually we'll start to see Orion re-enter the atmosphere. It'll go through those skip maneuvers, and they'll lose contact with the spacecraft for quite a bit while it's going through the atmosphere and it is surrounded by plasma. And eventually, once it comes out of that, we'll get the signal back from Orion. NASA will tell us if it's looking good. Chutes will deploy, and then it'll land down off the coast of, I think, Baja California. I want to look at exactly where the new landing location is.
Okay.
New landing location. Orion.
What are your thoughts about what has been accomplished in setting the stage for a crewed mission 2 years from now?
NASA decided on a landing site in the Pacific Ocean near Guadalupe Island. So,
Okay.
Google Maps. Let's take a look. Guadalupe Island. Okay, so let me bring this up on stream for a quick moment.
The major objective of the mission lies ahead. That's the rigorous testing of the the heat shield, as we've just seen in our features. 5,000 degrees Fahrenheit building up around the spacecraft. Twice.
All right, this is massive. We need to make this a little bit smaller.
How do you think
Okay.
it's going to fare, and what then needs to be
Okay, so as you can see, it is off the coast of Baja California. Obviously, that is Mexico. It's still pretty much kind of like almost due south of LA, but it looks like Guadalupe Island is quite a little bit off of the coast from Baja California. But that red pin you see on the map there is Guadalupe Island, so they'll be landing somewhere right near there.
So this is just one of many tests that we have going forward, and one of many analyses that we need to do with all of the post-flight data that we retrieve.
Maybe we could talk about, not only we've been talking about Artemis 1 and how things have been going so swimmingly with it. What's next after Artemis 1? Maybe we can talk about Artemis 2,
Sure,
which
and
is
while we're
the
talking
follow-on
about it,
mission.
I can bring up the Artemis 2
Okay.
map.
Yeah, and that mission has been advertised as a very close to the same type of mission as Artemis 1, except instead of doing the near retrograde orbit, it'll be just doing the what they call a free return orbit, which essentially just sends it out toward the moon, and if they do nothing, it'll come back and land fine. So it'll be obviously a lot shorter than the 25-day Artemis 1, but because we have people on board, they're not going to take as many risks. They're taking the risks now with since there's no crew on board. And so, yeah, so it'll be basically just the big old, like the figure eights they used to do with no, they will not go into orbit with the around the moon, but they'll allow it to come back, which is kind of disappointing from my book. I was hoping for some more orbital time around the moon to look at pictures of it, but definitely they'll get a lot of experience with the astronauts aboard, getting to check out the equipment. Also, I noticed they're going to do some proximity operations demonstration between the Artemis 2 Orion capsule and service module with the second stage,
Right.
With the interim cryogenic propulsion stage, and I'm assuming that's kind of teaching people how to do that kind of on orbit maneuvering. One of the things that was a make or break for the Apollo missions was that the whole thing was planned around what they call lunar rendezvous, and what that meant is that at some point during the mission, the lunar module was coming up from the moon to meet back up with the command service module, and they'd have to rendezvous in orbit. And
Right.
learning how to rendezvous rockets, spacecraft, was something they learned how to do during the Gemini days, and it's not as orbital mechanics is relatively easy to understand these days. But back then they hadn't figured it all out yet. So they did a lot of test flights, and they had targeted Agena target vehicles they would launch before a Gemini flight, and then the Geminis would go after them and target them and learn how to dock. So that's experience that you have to give people. You can do as many simulators as you want, but it's not as good as the real thing. So I can see why they would want to do something like that. They'll do proximity ops. They'll get used to it, because as we go into Artemis 3, eventually they're going to have to dock with Gateway, and then they'll have to undock, climb into the lander and undock the map. So the more experience these people get, and the more data that the engineers can get, the better. And
Right.
understand, because right now the Orion capsule's been out free flying by itself. They have not spent any time with the vehicle working around on other vehicles, which will happen with obviously with the Gateway and the lunar landers and so forth. So this is, I think, going to be very interesting. That should be a very TV worthwhile moment to watch when they fly around. It'll be something I imagine it'll be something very similar to what they did when they extracted the lunar module from the third stage in the Apollo moon missions, where they have to go in. But in that case, they were just getting the lunar module out, and then they disposed of the third stage.
Yeah, it should be really cool to see. I really can't wait to see like the footage of crews involved with these missions actually up in space in Orion doing this.
Oh yeah, it's going to be, it's the quality of the video is, as a television engineer, video image quality is always very important, and having spent most of my time at NASA dealing with standard definition television, old NTSC analog, just got into digital, and we played with high definition the last 5 years I was there, but it was very limited. To see the quality of the video they're getting now, is just amazing. I'm just so proud of everybody there.
Yep, that's amazing. It's amazing. in continuing on the conversation about different things that they'll be able to test with Artemis 2. One thing I realized that wasn't installed in Orion was basically the climate control systems for Orion. So it's interesting that they didn't want to launch this one and test all those stuff as if crew was on board. But that will be a new thing that they're testing when the crew is actually on board in Orion. From what I understand, it wouldn't have been a very comfortable ride this time around without all the climate equipment on board. So that's another thing that they'll have to test out with Artemis 2 with crew on board.
Yeah,
so that'll be interesting.
Yeah, I'm sure it had to do. It was a, NASA is on a budget, and they have to justify everything. And then they realize, well, since we're not going to have a crew aboard, we don't need to have that high a fidelity environmental system. I'm sure the temperature is controlled in there because you have a lot of sensitive equipment, electronics that can't overheat and get too cold. But that's electronic equipment is probably a little more durable than the human body when it comes to that kind of thing. So. Yeah, that's obvious that they needed to prioritize their testing, but no, I'm sure they're not going to wait to test it on Artemis 2. They'll have tested it thoroughly in advance.
Yeah, on
so
the
the
ground.
crew really will have nothing to do with it. Yeah. I'm sorry, I was listening to Rob Navius talks. I have to listen. It's unfortunate.
Just to get the
unfortunately,
update.
Yeah, I've spent a lot of time working with Rob over at the Johnson Space Center for better part of 10 years. And when Rob talks, you listen.
Absolutely. He's one of those voices that you'll always recognize from these.
Yes. Yeah, absolutely. The Rob is a fixture there. And it's funny, there's very few of us remember this, but in the early days of the shuttle program before NASA TV, or back then it was called NASA Select, was actually available on local cable systems. There was a group called Dial-A-Shuttle, and it was sponsored by the National Space Society. And basically, they had people sitting at the Johnson Space Center Public Affairs Office. They had a table, and they had just sitting there, and they would take an audio feed from NASA for their commentary and air to ground, and then they would do their own commentary also. And you could dial an 800 number and listen to it. And I was living here in Houston, and was still single, living in an apartment, sleeping on a mattress on the floor, and I'd have the phone. Didn't have a speakerphone. I just put the phone down and listen to it as I fell asleep and so forth. And there was a gentleman who would have this very distinct voice, the voice of Dial-A-Shuttle, and his name is Peter Crew, but I didn't know his name at that point. And then last year, actually, it was earlier this year, when I was volunteering at Space Center Houston. I got word that, hey, you're going to have a new volunteer coming in and you're going to work with him. And the gentleman walks up and it's introduced him and says, "Hi, my name's Peter Crew." And his voice woke all those memories I had. And says, "You were with Dial-A-Shuttle." He goes, "You're the only person who remembers that."
That's amazing. That's awesome. Yeah. So what we're seeing on screen right now is one of the tests that NASA has previously done to basically do a mock of these operations to secure the vehicle after it splashes down. So they had an Orion simulator. They just had a capsule, not a full Orion capsule, in the sea, and they tested all the preparations of how to get it onto the ship and secure it and everything. So this is something that they did to just prepare all the teams to make sure everybody's ready for the real deal when it happens. I'm trying to remember back to EFT1 if they had basically the full recovery operations engaged at that point, or if it was just like, let's just go pick the capsule up, not.
I don't remember actually seeing. Yeah, I don't remember seeing any footage of the splashdown. I remember there's news stories about it, but I don't remember at what level. I imagine it was just a matter of, it was considered a boilerplate, so there wouldn't be the same level of staffing and manpower. They just could have gone out there with a crane and picked it up. It's interesting to find out, in the Mercury, Gemini, and Apollo days. Well, to clarify that, I believe in the early Mercury days, the plan when they recovered was they went and hooked the Mercury capsule and brought it aboard a ship, and then they got the astronauts out. With the Gemini, that's when they started opening the doors in the water, or on the water, and have them getting out and then lift them with a helicopter. And then, of course, the Apollo missions, they did the same thing. The scuba divers crew got out there, put the ring around it, opened the door, got everything, and then they lifted them up on the helicopter. But now Dragon, SpaceX Dragon capsules, actually, they're doing the lifting. They leave them in there, they pull it up, they lift them up and get them out. And I'm wondering if that's what, based on what I'm seeing here, it looks like that's what they'll do for the manned missions for the Orion. They'll bring it aboard like that. It seems to be the safest because you're not opening a hatch in open water, which can always be dangerous.
Right.
And since you have your accuracy of landing is so much better, you're going to be relatively close. So it's only a matter of minutes, less than an hour. I think that's what the time that the SpaceX crews, the crew that when they're coming back is less than an hour.
Yeah.
So that's interesting to watch it.
I've just added to the stream the IBM feed of just like the raw Orion video because on the official broadcast they keep going to and from it. So I thought it'd be a good idea that when they're not showing that video, we'll have that up in the corner there. So for anybody that's watching,
I'm seeing it on there now. And it looks like it's doing some pretty hefty maneuvering right now because the Earth is changing orientations in there.
Oh yeah, yep, absolutely.
Hey, could you do me a favor and drop that link into the Discord for me so I can grab it so I can have it up here too?
Absolutely. There you go.
Thank you. Gotta love Discord. There it is.
So obviously it drops out sometimes. When you see the big Artemis logo, that just means the video feed isn't available, but it'll come back automatically when it is.
Okay. All right, got it. All right, I'm gonna put that kind of down in the corner. I need more monitors. I think I have a justification
under 1
to buy some
hour
more.
officially.
Yes, I saw that. That's fantastic.
You need some more monitors, you were saying?
Yeah, I need a second monitor. I got to do them. I've only got my MacBook going here, which is fine for normal stuff, but I need a couple more. I need my own mission control. Let's be honest. I need my own mission control. It's funny. It's funny I should have brought that up because I just had a memory, once again, back to the Apollo days when my brothers and I were younger, was that when by the time we got to the moon landings, it was a lot more attention. And so you'd get break-ins in the daily news. And, soap operas would be interrupted for things like that. So my brothers and I, there are 3 other brothers, 1 older, 2 younger. We would go down to we would create mission control in our basement. We basically had this long thing. We'd take a sofa and push it away from the wall. And we had some wrought iron frames for some glass top coffee tables to create and put on top. And then we'd put black and white TVs in there and get typewriters and make our own computer terminals and make our own headsets and have the big screen on the big 21-inch TV in the front of the room would be the big screen display they would have there at Mission Control, so we'd watch it and so forth. And I wish everybody could have that kind of enthusiasm about space like we did, because we're making it up as we go. In fact, I remember making headsets out of coat hangers, which hurt.
Oh, I love those stories.
We put them on,
That's amazing. That's amazing. We have Andras. Andras, I'm definitely butchering the pronunciation of your name, but thank you. Where are you watching from? Are you from Hungary? Are you one of the Space Junkie folks? We've had great support from the Space Junkie channel based out in Hungary, and we've been collaborating a little bit. And they're such an awesome group, and they got a really cool channel going on over there.
Nice.
Cool stuff.
Yeah, it's great to be able to connect with other people around the world for this kind of stuff, because it's no longer just the U.S. space program. That was one of the things growing up was the U.S. space program. We had a lot of pride in the country, justly so. But one of the things NASA was very good about not promoting is just the U.S. program. If you look at any of the plaques that we left on the moon, we didn't talk about the U.S. landed there. We talk about all mankind. We left an American flag, but that's just to show which one of us did it. But they always spoke in terms of it being a human effort, not a individual company's effort.
Yep, we're all in this together. We're one planet, and we go to explore together, right?
Yeah, exactly. Well, and that's the realities of doing space exploration is obviously proven itself out with the International Space Station. And that's one of the things people talk about, well, who's going to go to the moon, who's going to get to Mars first and stuff. I said it's probably going to be all of us, because they're no one country can afford to go by themselves.
Right.
And International Space Station is a perfect example of that. It's much better to share that kind of thing, that kind of activity anyway. So why not? And of course, the Chinese are right now making great leaps and bounds. They've actually been openly talking about their plan for landing humans, the Chinese Tonkanauts on the moon within the next 5 or 6 years.
Right.
So it's a very big deal. And at this point, I would say the Chinese are proving their mettle. They're proving that they can do what's required.
Yeah.
And when it comes time to actually go to Mars, that they will qualify as an international partner and not just be. And nothing against the rest of the other international partners. They provide what they can, but the infrastructure is all there. The Chinese building up a very nice infrastructure with their hardware and an amazing hardware. They've now done their first space station handover, so now they're going to have continued presence. Hopefully, they'll keep that going. And all that learning, they're learning what NASA and the rest of the world has learned over time. So they've, for lack of a better word, earning their way into the International Space Club. And once they're proven, hopefully they'll be brought aboard, and we'll do this as a planet and not individual countries.
Absolutely, that would be really great to see. Yeah, we'll have to see how that relationship develops between us and them as the moon missions are impending. That'll be something certainly interesting to see, and I think a lot of people that study like international relations and stuff are going to be really interested by that time period. So it's going to be fun.
Yeah, absolutely. Yeah, once again, it's a great time to be alive.
It is.
I got to get T-shirts to say that. That'll save me time saying it. So.
And Andras, again, sorry if I'm pronouncing your name wrong, confirmed they're one of the Space Junkie folks. So thanks for joining us here today.
Right.
And they also said, for all mankind, Orion spacecraft with the European life support module is a great example of collaboration. Absolutely.
Absolutely correct. Yeah, and one of the other great collaborations has been Canada and their robotic arm, Canadarm. They've recently they were doing the development work on the Canadarm. They're going to have aboard the Gateway. It won't be quite as big, but it'll be very, very sophisticated. Be able to do a lot of extra work. What the idea behind developing an arm that can do some of the work outside, they would have to do as spacewalks, because spacewalks are very dangerous, and they try to limit them to as least number of as possible. And so a really good remote manipulator is important.
Absolutely.
But there are plenty of other countries providing their support and hardware and so forth. And that's what's great about the international partnership right now is people can individual countries can take their technical expertise and apply it to our travels, our exploration of space.
Yep. I want to see more and more of that. But yeah, Canadarm's been like honestly the greatest example of collaboration with the ISS and just that. The ISS would be in such a different situation without that piece of hardware and technology.
Oh yeah. I remember some of the early before the space station as we know it now. There was Freedom. Freedom was the late 80s, early 90s version they were pushing for. It was drastically different, and I don't believe, maybe because the designs never got as mature for that time, because it was basically being sold off at a political level, that they ever talked about the hardware, the remote manipulator arms and stuff like that. But there were a lot of really fanciful drawings about that space station, and it looked all great, but it looked had a real 2001 feeling to it. If anybody remembers the Stanley Kubrick movie and the artwork that inspired a lot of that work. It was great to dream, but it as usual, it was when they eventually did not fund the space station Freedom. A lot of the work they had done in it previously was then rolled over to the International Space Station. They tried not to waste any of that work. Same thing with like the SLS, which is all part of the Constellation program. I mean, if you look at the original Constellation heavy lift vehicle and the SLS, it's almost the same vehicle.
Yeah,
almost identical.
It's it was like the Ares Block 4 or something.
Yeah, there was Ares 1.
Yeah.
The Ares 1 was going to be essentially the Orion capsule, which was called something else at that point, on the top of an 5-segment SRB, which was an amazing concept. I happened to be out, where was it? It had to have been 2005, because that was the return to flight after the Columbia accident. I was out there working for HDNet, Mark Cuban's high definition television network, and they had worked out a deal to show the return to flight in high definition, broadcast in high definition. We were first high definition television network in the country, so we came in and set our gear up and basically fed NASA the high definition logos or camera feeds and so forth. But that was one of the things that was building up, was the Ares 1 project was building up at that point. And just that was the first time, because I hadn't been able to pay attention to stuff, to see them SRB, and I actually got to go kind of stick my head into the VAB as they were stacking it. They were beginning to stack it, and they basically took they still had all the shuttle, shuttle hardware. They basically took one of the mobile launch platforms, and they just stuck one SRB on it, and then they lifted the boilerplates. There was the second stage, and the capsule, that was all boilerplate. They just loaded on there. And the whole idea was they're going to launch it and see how it performed, get some engineering data on it. And if I remember correctly, they had a little problem with Pogo, not Pogo, what do they call it? When they separated the SRB shut down and they separated the upper half, this would have been the second stage, and the capsule, it separated out, and then the SRB kind of caught up with and bumped into it a couple times, which is something happened during the early Gemini days. Some of the early development, they were having that kind of thing, that you have to have really good separation so you don't bump anything. In fact, if I remember correctly, Starliner 1 had that problem, or may have had that problem. I think that was one of the software glitches that could have caused it to run into, and that's always a bad thing.
I got the Ares 1X video going right now on stream. So this is the launch of the first and only Constellation mission launch ever. So this was an SRB with I think it was Orion mock-up on the top, right?
Correct, but it wasn't called Orion at that point. I would think it was called something else, or may have been called Orion, but it was all boilerplate hardware, just mass simulators.
Yeah, and it didn't even make it to orbit or anything. It was like they just launched it and separated, and that was pretty much the full test.
Yeah,
crazy.
Well, they needed to get the whole concept of putting manned spacecraft on top of an SRB, which it's with a liquid fuel rocket. If you have an issue, you can shut it off. An SRB, solid rocket fuel, no, it's all or nothing. And once it gets going, you have to make sure that you can stay within the safety envelope. And so they needed to get the data, and they had the hardware and the opportunity to do so. So they did.
It's interesting. And just seeing crew on any rocket with SRBs, like nowadays, like some people just like have concerns about it and are wondering if that's really still the way to go. But I mean, I don't know. Obviously, there's history that the SRBs have caused a problem before on human spaceflight, but I don't know. I think I don't think they are. It does have the limitations. You're not able to throttle and do this and do that and shut it off. But as long as you have escape systems that can handle that, then I think they're still an important piece of technology that could still be used in future rockets. But it's funny that we're seeing Starship, no solid rocket boosters. The new Vulcan from ULA will have configurations with solid rocket boosters. And actually, I think it was Northrop Grumman. They were planning an Omega rocket, and I think that was just SRBs, but that project's kind of died out. But
I believe that was one of those SRBs. The Chinese are using a lot of smaller rockets that are just nothing but SRBs. Some of their commercial Chinese companies are doing just SRBs because they're very simple. They're not a lot of, you don't have to worry about the plumbing and so forth. But to your point about using SRBs with manned spacecraft, the SLS and the Orion system has an escape system, the old-fashioned Apollo type LES type escape system. So that kind of worry goes away. They are, when you start talking about bang for your buck, liquid fuel SRBs solve a lot of problems because they're so simple. In fact, you can actually throttle them, but not manually. But what they do is when they design it, they can change the size of the throat of the exhaust. So technically you can, but that has to be all planned. But with the launch escape systems now, as mature as they are, those kind of concerns are really not as important as before. The shuttle obviously had some design flaws in it, and they were compromises along the way. And I hope that NASA has learned, and the reusability mantra has been kind of set aside. I know Elon's doing his reusability, but he's doing his from square one. And that's different than taking a vehicle that's not reusable and figuring out a way to make it reusable, that kind of thing.
Right.
But I once again, I'm surprised how mature SLS is. I mean, nearly flawless. I haven't heard anything. I'm sure there is some nitpick engineering stuff, but nothing of major importance.
Yeah. Yeah, which is, I think everybody got a little bit more renewed confidence in Artemis program after seeing it actually get off the ground and go well. I heard so many
Yeah.
people saying that it's going to launch and it's going to fail, and then Artemis is going to be done
Oh,
for.
yeah.
And if it failed, Artemis probably would have been done for. But we can see that all the engineering time and money that went into it. Now, granted, it's a ton of money. I don't think anybody thinks that it's priced appropriately, but we saw that all come together and it kind of validated the program a little bit, which was great. I always say, a lot of people are I'm team just like you. I'm team space. I want to see all the rockets succeed. If there's a more
Absolutely.
efficient and affordable way for us to do it, that's great. However, a lot of people are betting on Starship over SLS, and the way I see it is if Starship wasn't around, all we would have is SLS, and you never know what could happen
Yeah.
to Starship development. And if something goes wrong with Starship development, then we still can have SLS. And back when SLS was started to be talked about and created and stuff, Starship wasn't even conceived as an option. So
Yeah, absolutely. It's always good to have more than one option. That's why, like NASA's crew contracts for the International Space Station. That's why we have to have the second with Starliner. Unfortunately, it's been having its problems, and that's kind of one of those old space, new space kind of conversations. But the transition between old space and new space takes time, and nothing happens quickly. If you want something to change for the good and change permanently, it's good to do a slow change. And so as Artemis continues its flights into Artemis 3, 4, 5, and then once Starship has proven itself, people, and not only the Congress but also the public, will go, hey, wait a minute, here's a vehicle that does way better than you've got. Maybe it's time to transition this stuff over. And it's not like you just unplug one thing and plug in another. Obviously, there's different technical issues to deal with that. But the plan, obviously, is down the road is to hand everything off to a commercial entity to do. So when we start flying to the moon regularly to put people on the moon base, why not Starship? And then utilize the NASA money for the deep space exploration, going to Mars and on forward that. So
absolutely. Quick update on Orion's return. As you can see, the velocity on the bottom left is still increasing, which means it has not quite hit any sort of dense part of our atmosphere yet. And prior to it actually hitting our atmosphere, you'll see that service module at the bottom completely be separated. Just that silvery looking part will come off prior to reentry. But it's getting dang close. We're just about to pass under 4,000 miles distance from Earth. So that's nothing. That's it's further than I don't know, London from here or something. Like Orion's getting really close.
Not, and at 17,000 miles an hour, it'll go very quickly. 43 minutes. That seems like too short.
I know. That's what I was thinking. That's what I was thinking.
Yeah.
But the bottom right is the official countdown, and they're still planning 43 minutes. So, it's just under 4,000 miles now, 17,500 miles an hour. Pretty soon, I think we'll see that separation happen. Orion will be on its own. That heat shield will be exposed, and we'll start to see some reentry animations and maybe some live feed. We haven't had any live feed in 10 or 15 minutes at this point.
At this point, I doubt we're going to get any more live feeds because they probably maneuvered the solar arrays into probably a neutral position. So when they separate the service module, it doesn't have a chance of hitting it. So, and pictures at this point are probably secondary. I'm sure they have some onboard cameras recording it though. I'm going to ask if I could take about a 5-minute quick break here.
Absolutely.
So I'm not grinding my teeth just as we get landing. So I'll be back in just a couple minutes. Okay.
Sounds good to me. I'll take this moment to just kind of, for anybody that has just joined us, thank you for hanging out. We are currently waiting for Orion to return from its lunar mission and touch back down here on Earth. It's going to be splashing down in the ocean off of Baja, California. And we can see live views right now of mission control. Everybody's preparing for this re-entry. So this should be really, really exciting to see here. We're under an hour to go. We're actually under 45 minutes to go. So if you're tuning in now is the time to tune in. So So far, the Orion mission or Artemis 1 mission has been completely successful, based on what we've heard, at least from NASA. The SLS launch, they have been quoted as saying that was a perfect launch. So I'm really interested to hear when Orion's back down and splash down and they go through all the engineering data, to hear how successful this mission actually was, or if they did have any unexpected issues. So things are going great so far here for the splashdown today. If anybody has any questions about what's happening, please feel free to put those in the chat. We'll do our best to answer those for you. I appreciate everybody's support here today and joining us for this big event for crewed missions. You know, this capsule is not crewed currently, but the plan is to crew it next launch. So yeah, that's what we got going on. So you can see on the left-hand side here from the NASA stream that they've added a timeline to the bottom, or a progress bar, I guess you could call it. So the next thing we expect to see is the separation between the command module and the service module. So just a few minutes ago, when we had that animation on screen, I explained how the capsule itself will separate from the white part, or the service module, and just that capsule will successfully come back and land splash down. Now the service module will re-enter as well. However, it won't survive the re-entry. And then after that happens, we should see. Oh, there's the animation I was talking about there. So that is the Orion capsule on top, that silver part, and the service module underneath it, with the solar arrays and everything attached to it.
And I'm back.
Welcome back.
Thank you. My
added...
grandson just made a visit, so.
Oh, nice. They added a. Is he going to be watching the splashdown?
Yeah, they're setting it up downstairs right now.
Very cool. Once they switch back away from this animation, they added a new progress bar at the bottom, which shows, you know, separation and then re-entry interface and then parachutes and stuff.
Very good.
That's good to see. Velocity is still increasing. That's going to keep increasing until separation. But we're just about to pass under 3,000 miles. Like we were just talking, the last 1,000 miles went by in 2 minutes.
Yeah, absolutely. They're going to increase speed because Earth's gravity is pulling them in, pulling them toward the Earth, and then that won't reduce until they hit the upper atmosphere, which will start slowing them down. And hopefully we'll see. Hopefully they'll have some graphics about the skip maneuver they're going to do, something that hasn't been done before.
Yeah, I'm surprised that's not on the timeline, on the bottom there.
Yeah, well, I think it's still optional. I'm not sure they're going to do it. It has to do with if they have issues, if they want to fine tune the landing, they use the skip maneuver to reduce the amount of speed they have, burn off the energy.
I'm really interested by the right screen that they have up there on mission control. This is basically what the crew would be seeing if they were looking at the dashboard inside the vehicle. You got the Is it still called an artificial horizon on a spacecraft as opposed to a plane?
Yeah.
So you got the artificial horizon there, and then on the right you can see some. You can't make out any details, but there's something that keeps ticking down, which I guess would be its altitude. And then something should be ticking up, which would be its speed, but I don't see where that is. But it looks like the artificial horizon just flipped. So Orion right now is probably doing a maneuver. So it's cool to see that information. I wish we had access to that dashboard.
I'm afraid ITAR would have something to say about that.
Absolutely.
Yeah, that's something else that has been a very, at least during the countdowns, the people from the ITAR, I forget what ITAR stands for. Essentially, it's international. It's a regulation about technology transfer from U.S. technology to the world, and they try to limit some of that stuff. And for some reason, the countdown was very heavily censored. You didn't hear a lot of the loops that you would hear otherwise. In the shuttle days, you'd hear all kinds of loops and people talking. A lot of the information was decided it was too valuable or technically sensitive, and so you didn't hear it. So you'd have long, uninterrupted minutes of silence, and occasionally the public affairs officer would come on and talk, but he could only give you some information. And with all the hydrogen leaks, I could tell he was getting very frustrated because he had things he knew, but he was told he couldn't say. So he had to be very particular with his words. But once we got the mission up and running and flying, the commentary was wonderful. They were back on par with the shuttle program commentary.
I'm noticing. Sorry to interrupt. I'm noticing that a couple of those helicopters that were on board here are no longer there. So apparently
That's right.
they've taken off in preparation for splashdown of Orion. It would have been cool if we got to see those shots, but it's just cool that we're getting these videos in general. There's another recovery craft right there. It looks like a smaller, quicker boat.
They call that a fast boat.
Fast boat. There's looks like there's a lot of people on there. At least five people maybe.
Yeah. And people, I don't know if you in some of the video they've shown the rear of the ship they're using. What is it? The USS Colorado?
I actually missed it. I'm not sure.
Oh, it's a I forget the category of ship, but basically the back end opens up and you can amphibious vehicle ship. That way, boats and small boats can move up into basically the garage, and they can recover. And that's of course how they'll bring the capsule aboard, which is way different than as we discussed earlier in the old days, when they would have to pick it up with a crane or to get the crew out and so forth like that.
Right. That's really cool. They're giving us great coverage here. I couldn't have asked for more, to be honest.
It sounds like they had crew module service module separation, so now the capsule is by itself and it's maneuvered with the blunt end toward the Earth. Something else. If you look in the center of the mission control, you have a map. You can kind of see a map of the Earth. The vehicle appears to be coming up. It looks like, I'm looking at it, a little bit like it's coming over Australia, moving its way. It's not the normal orbital track that we're used to seeing with the space station and the shuttle. It's coming in, from a higher altitude coming down. So its point of crossing over points of the Earth are a little different.
Yeah, they've shown that graphic a couple times, and it shows that green orbit line. And for the last 3 or 4 times I've showed it, that green orbit line terminates off of the coast of Australia. But what I think that means is that at that moment, it is no longer in orbit, it is in atmosphere, and then it'll take from the coast of Australia to off the coast of Baja California, Mexico, to actually come down through the atmosphere. So I don't think that line is the re-entry line is not actually shown on that graphic.
Yeah, correct. That would be that point at which it leaves space, and because it's called entry interface, where it touches the first part of the atmosphere, and that's of course when it'll start to slow down and drain off more and more of that energy.
Looks like some pretty rough seas out there.
Yeah, it's a little chop going on there. Not too bad.
Actually, I guess not too bad.
I'm curious. I know they would have limits for manned vehicle or crewed vehicle. Excuse me. But at this point, I mean, this is the secondary landing location, so obviously they had to move it away from worse weather.
Yeah.
So this may be the best they can get at this point. That's the one thing, like with the space shuttle, or even like with the Crew Dragon and the Crew Starliners, if there's weather problems, they don't even undock from the space station because it's such a quick return, so they don't have to sit in orbit. This one didn't have an option. It's coming home, and there's no parking orbit. There's no slowing it down. They only have a little bit of leeway of where they can go, so this is the best possible weather they could have and keep it close enough to be feasible. So
I'm looking for I got something that I could put on the board behind me that would be excellent for this occasion, but I don't know where it is.
Oh, yeah. By the way, I forgot to compliment you on your mural behind you, the astronaut on one knee there. You know what that's called?
No, actually, I found it. It's some digital art that somebody made online. I used to know the artist name. I have it saved down and stuff because I actually sent him a message just saying how awesome it was. But I found this just kind of on one of those those sites that anybody can post their art and sell it on Canvas and stuff. So I bought a big copy of it, and I love it. I should you know what, I'll get that artist name again just so if it ever comes up on stream I can give them a shout out because it really is beautiful. It's amazing.
Yeah, I love that.
Give me
unfortunately
30 seconds. I'm going to try to find something.
Okay. Well, watching our NASA TV feed coming in here right now, you can see one of the fast boats maneuvering around. They're preparing in their staging areas before the Orion capsule comes in for splashdown. It's currently, if I remember correctly, it's still 12 minutes away from entry interface. So, yep.
Okay, I'm back.
Okay.
It's a little bit smaller than I thought. I was gonna put the Artemis logo there, but I got this patch. So the thing I like to do is I like to go get mission patches for any launch that I've seen in person. So there are a couple that I'm specifically proud of, and Artemis is one of them, and Inspiration.
Oh yes,
where were
you were there? Where were you for Artemis 1? You didn't make it out to the VIP area.
Right. I was in the I was just at the general visitor complex for it, and it was actually a beautiful view. I will say that next time, I would love to go at least to the Saturn V, Saturn V Center, for Artemis 2, just because all the sound from all the videos. Oh my goodness.
Oh yeah.
The sound was great from the visitor center. It was actually very, very beautiful from the visitor center as well, but I got to see it once from Saturn V.
Yeah, the Banana Creek viewing area used to also be known as the family viewing area back during the shuttle. Of course, is where the Saturn V is now. It's 3.9 miles from 39B. So technically, we were the closest civilians to the launch, and there was plenty of other NASA folk and visitors and guests like that. But there you have a clean view all the way to the pad. It's just water and marsh, so you can see the pad. You can see the bottom pad. We could see the engines light up and so forth.
That's awesome.
And the burn. I remember specifically. I was like, people like, oh, don't look, it'll burn your retinas. I'm going, no, I want it to burn my retinas. I want to see that burn into my memory and so forth.
So bright. I was concerned for a couple minutes about my vision. I was like, should I be looking at this? But I don't. I mean, I don't have any noticeable sight decrease, so it was worth it.
Well, we'll see. We'll see in about 30 years.
But Greg Love says, great info. Appreciate you guys streaming. Is your board Starship tiles? Thanks, Greg, for joining us. Your support is awesome. So they're not actual Starship tiles, but I did make this back here to be based off of Starship. But what I realized just yesterday is that they're not oriented correctly. So maybe I have to rotate the board and fix it up a little bit.
Yeah.
So they're supposed to be. Actually, I can demonstrate what orientation is supposed to be with my heat shield tile tattoo.
Oh, nice.
Yeah.
Oh man, that's fantastic.
So it's
it's also very much JWST, James Webb Space Telescope.
Yep. And thanks to you.
You painted them gold.
I don't think I actually ever thanked you for sending me this, and I apologize for that. So I will take the opportunity right now to say thank you so much for sending me this patch for the JWST.
You're welcome. That's a very, very good patch, and it became so popular it actually became very hard to find. Everybody was selling out of it, and I lucked out. Was over at Space Center Houston, and I just went in there, and they had just received their limited supply, so I grabbed them and ran out the door.
Yeah.
Or they could stop me.
Amazing.
No,
Amazing.
I paid for them. Yeah, I paid.
Oh, I know.
But yeah, I love sharing that stuff. You can see behind me, I've got patches on the wall, and that's 1/10 of 1% of my collection used to be back in the 80s and 90s. Unfortunately, kids and braces kind of thing happened, so I ended up having to sell quite a bit of the collection. But you can still see there's 2 flown patches. I can't point like that. Right there. Here we go.
Gotcha.
Those are from Eileen Collins. Her 2 flights that she flew the first time. First time she flew as a pilot, her first female pilot, and also first flight as a female commander. I got to work with the crews, a lot of crew training going on for television and things like that. And she was nice enough to fly a couple patches and then given to me, autograph and their whole 9 yards. It's part of I actually had more, but like I said, kids and braces, I ended up having to sell them. But those are the 2 I refused to give up.
Right.
It looks like we're getting a map now. Is that your map?
You're seeing a map?
Oh well, I'm watching the stream on the other side, and it's way behind. I think
gotcha.
it's so delayed. Yeah.
If you hit the little live button, it should catch you up. That was a while ago.
Oh man. Oh, sorry, technology is tough for me. There we go.
No worries at all. But I do want to actually point out On the live, so up on the top right hand of our stream here in the IBM feed that I sent you, we're getting a live footage of something. I can't tell what this
you know what that
is.
is? Hold on, so let me get it up here. Let me see if I can see it live.
This is like a
Okay.
porthole looking out.
Yeah, I think it's either it's probably one of the windows in the capsule with a live camera, so they can watch when they start seeing entry interface, and
Okay.
and you can see the flames. The only other thing I can think of would be a live shot of the parachute compartment, so they can see the drogues deploy, kind of like
That
they
could
do with
be.
Dragon. Yeah.
Yes, for anybody watching the stream, that video feed above Titan there, at the top right of the stream, that is a live feed from Orion. Now, occasionally they will show that on the feed, the main feed over here on the left, but they're switching from a bunch of different scenes on that one, so we wanted to keep that live direct feed from Orion up top there. So I'm seeing a lot of little artifacts kind of in that stream from whatever this is from. I assume that's ice and stuff breaking off of Orion. It's just like little particulates, so who knows what that is, but
Could be. Also, this is probably not full frame video. It's probably a slow scan, like a 10 or 15 frames per second, because it's going to be streaming. And normally, when you have a vehicle, when the shuttle returned, it had a couple minutes of no LOS because of the plasma. But in the later days of the shuttle, because of the orientation of the TDRS satellites, there were on rare occasions where they were able to maintain complete data coverage because the satellite was right behind the orbiter, and so they could the signal could get out and not be affected by the plasma. I'm not sure if that's even an option with Artemis, but since Artemis has been flying mostly on utilizing the ground stations and not using the TDRS network, I'd be curious to see if maybe they're switched to the TDRS and maybe they'll be able to do something like that.
Yeah, that'd be interesting. I'd like to point everybody's attention down to the bottom left, the information that NASA is providing for the telemetry. We're just about to pass under 500 miles until, for altitude, of course, until Orion is splashed down. That velocity is continuing to increase, so we haven't hit that dense part of the atmosphere yet. I'm assuming there'll be some animations around the base of that vehicle when they're starting reentry and seeing that plasma. But those miles are coming down real quick, and I'll try to point out when we start seeing that velocity decrease. But we're getting close. If anybody has this on in the background while they're multitasking, I think now is the time to tune in, and the excitement's about to begin. And Greg is asking, can you tell us about your guest intro? So that's a good point for anybody who's trickled in. Titan, you want to let people know who you are and where they can find you on social media and stuff?
Absolutely. My name is Andrew Paris. I worked for NASA for 13 years, from 1987 to 2000. I worked 3 years out at the Dryden Flight Research Center, which is now called Armstrong, doing television coverage of the shuttle landings. And then 10 years, 1990 to 2000, in Houston, working at the Johnson Space Center. Worked all kinds of different variations of shuttle television, space station television. Did a lot of traveling. Used to scuba dive with the astronauts doing their EVA training. Flew on the Vomit Comet, which we now call we don't call it Vomit Comet anymore because that's they don't like it when you say that. But it, flew in the microgravity planes. And I've been a space fan, space positive person since I was 7 years old, and love space. I've recently just got back into it and started getting into working my way to become a commercial astronaut. I'm working to try to become get a flight into space, and welcome everybody who wants to join me on that. We have Lambda and I. Andrew's call sign is Lambda. We're part of the Inspired 24. It's a group of people that met during the Inspiration 4 mission in 2001, September. Yep, there it is. I got a drawer full of them over here. Yeah, here we go. So I got my patch here. Yeah, there we go. The Inspired 24. And basically, we're just a group of people all wanting to go to space. So we're trying to help each other do that. At the same time, trying to educate and inspire people about our future in space and everything that goes with it. Big into STEM. We do charity work for St. Jude's, and also now I'm going to start doing some work for Astro Access, which is a group that flies people with handicaps on the zero-G plane, the Go Zero-G plane, which I got to do a couple of weeks ago with some other I-24 members who are part of the Space Plus 5 astronaut candidate class, including Ruben Salinas, who is going to go fly on a Blue Origin New Shepard mission next year. And we're all very excited about that. So basically, if you're interested in space and want to help be part of it, we welcome people. It's theinspired24.com.
That was great. Yeah, thank you for that introduction and everything. You've done some exciting stuff. I know that you recently went, like you said, you recently went back onto the 0G plane, and oh man, I think you got some exciting stuff coming up.
I finally got a chance to edit a little bit of the video. Let me see if I can drop it into Discord. Oh, you know what? I think I have it on. Where is it? On Dropbox. Hold on a second. That was the Artemis launch. Yeah, world now 0G flight. There it is.
I'll queue up my Artemis video for. I assume there'll be a little bit of, kind of downtime when crews are approaching the vehicle and stuff. So we can.
I'm gonna send this to you. I'm gonna send you a Dropbox. It's actually the social media release. It's just kind of their 0G's promotion for each mission they do there. You can drop that in, and we can show that later. But yeah, 0G is a lot of people on board the flight that day. With 0G, it's 0G, and I feel fine. It was pretty amazing. I said I used to fly for 0G for NASA. It was for work, and so I didn't get to play. A lot of times I was using a camcorder or looking through a viewfinder, which unfortunately made me motion sickness a couple times. And so it was work, and then I always wanted to fly again for fun, to get to experience it like astronauts get to do. And so an opportunity came up a couple weeks ago, and I was able to take it and fly with friends, which is even one of the most better parts is flying with friends. The flight was a little full too. Normally they fly with a crew of 28 passengers aboard, and but through some scheduling work, we ended up having some extra people on board, so we had 40 people. So a lot of people kicking each other in the head, which was a different experience.
Oh,
and,
I'm seeing
but it's still
some plasma on that top right screen.
Oh, yeah, I see it.
We're re-entering now.
Yeah.
We are coming through the atmosphere. Wow, we still got the video feed too. Wow, look at that.
Yeah, look at that.
We are now in the
and there's the loss of video feed.
Yeah. There's some famous film footage. I'm sure most people have seen, whether they didn't know what they were seeing or not. Was one of the Gemini missions. I believe it was commanded by Neil Armstrong. They were they docked with an Agena target vehicle, and then something happened and a thruster got stuck open, and the vehicle started spinning wildly, and they couldn't figure out what it was going on. So they had them undock. Well, as soon as they undocked, instead of tumbling the Gemini spacecraft and the Agena vehicle, all of a sudden it was just the Gemini capsule spinning around, and they had to do an emergency abort to land, so they had to fire the retro rockets to stop them. And there's a shot from the I believe it's from the pilot's window, which is facing forward, as it's going backwards and spinning and gyrating wildly back in the atmosphere, and you get to see that whole plasma effect. But they were spinning out of control. At one point, they nearly lost consciousness from the G's they were pulling.
Wow. So it appears that that video feed is gone, which is not unexpected. So Orion is definitely kind of in the thickest part of the atmosphere coming down now. This is really that point where make it or break it. We expect Orion to perform perfectly here, and let's hope that's what happens. But I'm gonna tune up the volume a little bit here on the NASA stream so we can hear any official updates.
Yeah.
As it approaches its splashdown site.
Oh yeah, and Greg was asking where to follow you on Twitter.
Me?
Yeah.
Yeah, sorry about that. Yeah, A Paris X, which is APARRIS X, at A Paris X. Yeah.
I'll put that in the chat as well.
Social media. Okay. Oh, I could put it in there. I guess I can too, huh?
Yeah.
I can type too. Look at that, amazingly. There you go. And let's see, I can even put Instagram in there since I'll put some good pictures in there.
Would begin about 6 minutes from now for about 7 minutes, followed by the jettison
There we go.
of the forward bay cover.
Technology, it's a wonderful
Begin
thing.
the
It sure
sequence
is.
of the deployment of
When
the
it works.
parachutes. First,
Yeah.
a pair of
All
drogue
right.
chutes.
So
three
there,
pilot
last I saw on
parachutes that will
the
then pull 3 main
speedometers,
parachutes
even though they were entering
to
interface, they were
begin
still
the
picking
final
up speed. They were
moments
getting
of
very close to
Orion's
25,000
descent
miles an
back to
hour,
its
which was
splashdown
always the
in the
magic
Pacific
number
Ocean.
for the Apollo landings. I was led to believe it was going to be going faster than that, but I guess it's very close to the same. But that's still the full test because they did not on the OFT one.
Mm-hmm.
Didn't actually achieve that great a speed because they didn't get that far out there. It was essentially, I don't think it technically actually went into orbit. I think it just went out like 35,000 miles, whatever, and then came back.
Oh yeah, EFT1, right? We got the EFT1 patch there at the top.
Oh yeah, EFT, yeah, engineering flight test. You got the E's and the O's, engineering and I and O for operation.
Yep, and like each company kind of uses a different, like OFT for SpaceX. It seems like they use OFT. And... Oh wow,
Yeah.
just under 15 minutes until splashdown.
Will be at an altitude of 274,000 feet, traveling just under 17,000 miles an hour with a range to splashdown of 2,000 statute miles.
Definitely some rocking going on that ship. A lot of people coming out onto the deck of the ship preparing for the splashdown, and then I think all those teams get real busy real fast as soon as that thing touches the water.
Oh, absolutely, yeah. So the fast boats will be making their way up there as fast as they can to secure a ring, an inflatable ring around it. Even though the vehicle, if you remember from the Apollo days, they had those 3 large balloons on top. That was to keep it so in case it did tip over, it would right itself. But they still have a danger of tipping or sinking, so they put a ring around it. Obviously, they won't be doing a hatch opening, so there's no need for a small life raft. Actually, if I remember correctly from the video they showed earlier, there was no ring around it. I think they're going to be pulling it in pretty quickly.
Yeah.
Excuse me.
We just heard
It'd be interesting to see how that changes.
Yeah. Well, I like I said, I hope that we get a video of that because that'll answer a lot of these questions, which would be so awesome to see.
Oh yeah.
But it sounds like we're waiting for acquisition of signal, which I'm seeing video feed pop up right now in the top right-hand corner, which is absolutely fantastic news. That means that Orion has successfully made it through kind of the harshest point of reentry. And the fact that we get in a video feed right now means Orion is happy and healthy and coming back down. So this is kind of the moment we were waiting for.
And we have
today.
data from Orion. Orion out of the blackout
absolutely.
period.
Oh yes, the video is even full motion at this point. You can see the Earth passing underneath it.
Yep.
That is pretty dramatic stuff. That is very impressive stuff.
Wow. So next thing,
I love this new technology.
That Orion is right
and then,
on
in fact,
money.
this camera may be in a position to see the drogue chutes and main chutes deploy, and that's probably the dual purpose at this point.
Wow! Look at the clouds and everything underneath. Still got some plasma going on.
Yep.
We should be performing the skip entry maneuver.
Yeah. Wow.
Momentarily.
Skip entry momentarily.
Okay. So we should see a change, a visible change in the altitude of the vehicle. See, there's some more plasma. Yeah. I think that was probably a thruster fire to maneuver. So now, because they fired the thruster, the vehicle has now changed its orientation. So probably its antenna became blocked, or maybe started to pick up some plasma, so it wouldn't transmit. So.
Yep. Yeah.
So now
basically,
they've
turns
dipped
into a. Go ahead.
Yeah, I was going to say now they've dipped down into the atmosphere, and now they're going to use the physical shape of the vehicle and thrusters to have it pitch back up and then come back up out of it, and then do the maneuver to come down.
It's so funny with space, just like space, pretty much like every space event. The most exciting part is almost always in a loss of signal, like when you're landing on Mars or when the capsule's coming back. It's just like every time that you lose that signal, it's just kind of like fingers crossed. Let's hope this goes okay. So
yeah, absolutely. Yeah, 2
It's,
minutes of terror. Was it 2 minutes of terror on the Mars rover landings? That was always.
I
Oh
think it
my
was
God!
more than
I
that, right?
can't. Yeah. I don't know. Have you? By the way, have you had a chance to see Goodnight Opie?
Not yet, not yet. I'd like to though. I'm planning on it.
It's an amazing video. It's promoted as the the life and times of one of the Mars rovers. It's actually about both of them, but it's actually more about the people.
Cool.
It's really a story about the people, and seeing the people that been there, started there. Actually, there's one example. I don't give too much away, but there's a young person who was actually a student there at the launch, and then came to work for the system, and was there through the end of the Spirit and Opportunity activities.
I would love
And of
to
course,
see
they've
that.
all gone to the thing. Yeah, it's I forget what streaming service. Anybody remember what streaming service it's on? Actually, I have access to the internet right here. Why not just use it?
I read a book. I read a book one time called. It was called Martian Summer. I want to say it might be by Andrew Kessler, and if I got that wrong, I'll double check this as well. But this was a journalist that got, or an author that got access, like full access to be in mission control for the Phoenix mission, which was awesome.
Oh
Like, and
yes.
it was such a great book. Such a great book.
Yeah. So
Martian.
Goodnight Opie is available. Yeah, Goodnight Opie is available on Prime.
Okay.
And it's definitely worth watching. It's definitely if you're having any interest in space, because I thought I had stayed pretty up abreast of what Spirit and Opportunity are going through with their daily reports and stuff like that, but I missed a ton of it. Yeah.
Yeah, I gotta check it out. Welcome Natano Ben. Hello, what did I miss? Re-entry is happening right now. Some moments of loss of signal acquisition. So we're kind of in the most exciting point right now. So you came at a good time. Soon we'll see more acquisition signal. It is currently bouncing off the atmosphere in its skip maneuver. And then after that, we'll see some chutes deploy, and we'll see this thing come splash down. So good timing. Andres says heat shield is under brutal heat load right now. Absolutely, we're putting that capsule through the test right now. This is that moment.
Yeah.
I think, am I making this up? I feel like I heard some stat somewhere saying that like the plasma around the outside of these vehicles for a moment is like hotter than the surface of the sun or something. Let me look up.
Yeah, actually, Yeah. Let's see. Let's see. Space will travel about 3,000. It's 5,000 degrees. Yeah. Yeah, the surface. It's funny about solar dynamics. The surface of the sun is not the hardest part. It's actually the corona, which is outside of it. So
yeah,
5,000
exactly.
degrees. That's some pretty good heat. I wouldn't want. I'd have to have some serious oven mitts to touch that.
Yeah. I always get blown away by the. There's always that like video that goes around from the shuttle heat tiles where like they make one side like red hot and the other person will just be touching it on the other side, and it's cool to the touch or whatever.
That always blew me away. And I actually when I was out in California doing shuttling operations, landing operations out there, I would talk to the guys like, "Is that really true? Can you really?" Oh, absolutely. That's one of the demos they do. Some of their engineering orientation when they go in there is they heat one up and then you pick it up and go. It's warm, obviously. You can't hold it for forever. But that's just the magic. I don't say magic. The sheer brilliance of that material, that it holds the heat and dissipates it a even amount.
Mm-hmm.
I remember somebody suggested using potatoes because they're so damn hot when you have a baked potato. I said, well, that's kind of opposite of what you want. It looks like we have some live pictures coming in now.
Yeah, it looks like there's a camera kind of scanning the sky looking for any hint of Orion. And then we got another live camera from the ship here, the recovery ship. And then we got another live video from Orion on the top right hand of the stream, which means Orion is still doing its thing. It's still coming back through the atmosphere. You can see the curvature of the Earth right there and a bunch of clouds. So the fact that we have video signal right now is a great sign that everything is going according to plan.
There is a view out of the cabin camera of Orion as it continues a series of role reversals. We have data back from the spacecraft. Flight Dynamics reports Orion straight and narrow on a true course toward its splashdown site. Forward bay cover jettisoning less than 3.5 minutes from now.
Okay, next big thing, jettison.
Yep. That'll expose the parachutes, the drogue, and then the mains.
Wow, that thing, you can
There we
tell
go.
how fast that thing is going right now. That's insane.
Yeah. Now, is that the same camera, or I think that's a different camera?
I think that is a different camera. Wow, look at that. This is insane. Oops, I got a pop-up going up for YouTube. There we go. Wow. They're giving us some live footage that we've never seen before on this mission. It's amazing.
Absolutely. Yeah, it is. Compliments to NASA and the team for getting that video. I have friends who still work out there at Johnson Space Center. They must be thrilled as I am about seeing this stuff.
Absolutely.
You can see as they're rolling. Yeah, that's part of the skip maneuver. The capsule, while the capsule is symmetrical, it has a center of gravity, which is usually offset to one side, and they can utilize that to create lift, either drag or lift.
Wow.
Kind of reminds me of the shuttle days when they would come back in. They wouldn't fly straight in. They would have to do what they call S maneuvers, and that was to burn off the energy from the shuttle from the coming in and to get them down to the speed where they were can handle the vehicle manually.
These maneuvers, if I was crew on board, these maneuvers would freak me out. I'm just looking at this being like, this does not look fun. Granted,
you never know. You get that e-ticket ride.
And the thing is, the crew is so well trained. This mission is not crewed, but hopefully eventually we'll see crew in an Orion capsule, and they will be so trained that everything that they're seeing happening, like right now, they will have seen all of this stuff in a simulation, so they know this is exactly what they're supposed to see. This is exactly what the vehicle is supposed to be doing. I'm assuming there'll be full motion simulators, and they'll know which pitch they're supposed to be at and everything. So, granted, if I was trained on all this stuff, I'm sure I wouldn't mind the ride so much. But if I was just in that capsule right now, I'd be like, what is going on?
Yeah, exactly. Yeah, talked to a lot of astronauts. Yeah, they do train you. You get very familiar, so you're not, your heartbeat doesn't get too high, but still it's like, oh my God, I'm in space or I'm flying a rocket kind of thing. Oh, now we got a good shot of that. The sun? I hope that's the sun.
Yep. Just under 4 minutes. 4 minutes.
50,000 feet. Wow. Amazing stuff.
Forward bay covered jettisoning pyros are armed.
I'm getting a little I'm getting a little sentimental. I miss Walter Cronkite.
Yeah.
His voice echoes in my mind. Sometimes I think about the Apollo days. And he was very nearly the first civilian in space. It was a very hard push to get him on the space shuttle missions, but because of the delay in the space shuttle program,
drogue chutes,
he ended up being just too old. Yeah.
25,000 feet.
Actually, it's interesting. We had people don't know this, but may not know this, but Dear Moon announced their crew this week, and one of our friends, Tim Dodd, was selected, and I was just so overjoyed for Tim to be going, because he was like, I just do this for fun.
Mm-hmm. No, that was amazing to see. Absolutely amazing.
And we have drogues.
Yep, we have drogues, so we should see those mains come out soon. Everything is going great so far on this mission.
Yes, absolutely.
2 good drogue chutes reported by the recovery team out in the Pacific. The descent rate is right on the money.
They should be able to see the capsule soon. Hopefully we'll get some imagery from the ship.
2 miles an hour. Range to splashdown 1.5 miles.
1.5 miles to splashdown.
10,000 feet now.
Wow.
All right, y'all. This is the moment.
Yeah, parachutes are the big deal.
Mains coming out in the top right, the live feed. The main feed's a little bit behind, but the IBM feed, we got mains coming out. Mains look like they are inflating.
And we're on mains.
They're standby for dereef. Yeah.
5,000 feet.
They'll stay reefed until it slows down. There we go, dereef.
Yep, looks like 3 good mains to me.
Reefing in progress.
Wow.
There we go.
3 good main
Briefing
shoots for
complete.
Orion.
Good
That's
names.
the hard part's done. Now it is, splashdown is about to happen, and then it's up to
We have
recovery
3
crews.
fully inflated main chutes. Time to splashdown 90 seconds.
Let's see if we get a live shot of splashdown. Please, that would be awesome.
Perfect descent rate
from the
reported.
capsule, absolutely.
Or just from a remote camera somewhere.
Yeah. Well, if they
Ship or
maintain this
something.
video, this is the best. This is the best image. Of course, they'd look great from the ship, depending how far away they are.
Is it down? No. Is it?
No, the chutes would.
Because
The
I see the
chutes
top.
would be paling.
Yeah, the top right hand. It almost looks like it's like a fisheye, and maybe you're just getting a little bit of ocean there.
Maybe
Oh, here it is.
a light glint. There it is. All
and
right.
there it is. High over the Pacific, America's new ticket to
Just
ride
like
to
the
the moon
simulation.
and beyond now in view.
Both of us and the official broadcast
Orion
just
under
said,
its
there it
chutes
is.
descending towards splashdown.
Yeah. Well, that's what you say. Oh wow.
That's amazing.
Yeah.
I think it's the new. I just moved to Texas this year. I think it's the new Texan in me that
Orion
when I
and
see
the
those
perfect-
shoots, I just think of Whataburger colors.
Yeah, absolutely. Absolutely. You're making me hungry, dude.
I'm starving at this point. Oops. Just wanna make sure we're-
1,000 feet.
1,000 feet.
Wow.
Good descent rate.
Yeah, I'm thinking back right now to me and you and some other guests on the first Artemis 1 rollout. We had a stream live.
Oh
and
yeah.
We were hanging out watching SLS roll to the pad. Eventually to see it take off, and it looks like we got splashdown. The main feed's a little bit behind, but that IBM feed on the top right just showed a lot of water. So.
Yep. There's water. And they lost signal. That's probably appropriate at this point.
Yep. It looks.
There we go.
Oh yeah, that looked
Splashdown.
like a good splashdown to me.
From
Yep.
Tranquility Base
Watch
to
for the
Taurus
3
Littrow
balloons
to
on
the
top. They
tranquil
should be
waters
deploying
of the
right now.
Pacific, the
I
latest
think I see
chapter
one
of
of them. Nope,
NASA's
not
journey
yet.
to the moon comes to a close. Orion,
Amazing.
back on Earth.
Those chutes should automatically
Unofficial
disconnect from the
splashdown.
capsule so they don't pull the capsule down.
We get claps in the chat. Heck yeah.
Yay.
Wow.
At a mission elapsed time of 25 days, 10 hours, 54
25
minutes,
days.
50 seconds. That's unofficial. Splashing down off the coast of Baja, California.
Amazing.
Yeah. Yeah, I see the balloons look like they're inflated.
The crew module uprighting system now being inflated for
Yes, big congratulations
bags,
to
currently
NASA.
being
Big
inflated.
congrats
Yeah,
to NASA.
absolutely. Everybody from the top to the bottom, absolutely wonderful job. I don't remember an operational mission ever going this smoothly, let alone a test
And
flight.
we have a report that Orion is
Amazing.
stable 1, upright, the way it should be.
Ooh, I got
Stable
the
1.
chills. I got the
Love
chills.
to hear that. Yeah. Stable 1.
Stable
Yep.
1.
Can't wait to hear that from a live voice inside that capsule next time.
Once again, splashdown occurring at
Now my cheeks are
11:40
starting to
a.m.
hurt. I'm
Central
smiling
Time,
so hard.
9:40 a.m. Pacific Time, west of Baja, California, after a textbook entry for the Orion spacecraft bringing its 25-and-a-half-day mission to an end.
NASA's Orion
Wow.
splashdown occurred at 12:40 Eastern Time, ending the Artemis 1 mission. I got my headline updated.
Excellent.
Awesome.
So we're going to stare at the rolling water for a little while.
Yep. So I'm curious how long of some coverage we'll have of recovery operations. But if you're free, feel free. We can hang out for recovery operations, or
Yeah,
if you
absolutely.
have things to do, no worries.
I'm I'm going to take a quick break, and I'll be right back.
Orion's
No, I'm gonna do that.
Be right
beacon
back,
is
everyone.
on. We
I'm
have
gonna do that as well,
confirmation
so we'll
that
just both
4 out
step
of the
away
5
for a
crew
couple minutes, and
module
we'll be right
operating
back with
system
y'all for
bags
more
have
commentary.
fully inflated, standing by for word on the
I'll put
5th
that
one.
in the chat. Be right back.
But Orion is in great shape.
There we go.
Stable 1, just in the orientation that had been expected. This is Mission Control Houston. Once again, the Orion spacecraft, having completed a journey of 1.4 million miles, bobbing gently in the Pacific Ocean. 4 out of its 5 crew module uprighting system bags have been deployed. We're standing by for word on the 5th. However, irrespective of that, it is in stable 1 configuration, in good shape according to the recovery team. And we are now receiving word that all 5 of the crew module uprighting system bags are fully inflated. So that's exactly what we had hoped for. Orion safely bobbing up and down in the Pacific Ocean.
Okay. I'm back. We'll wait for Titan to return. But successful splashdown so far. Vehicle's upright. It is looking good. We'll try to get some replays for you here. Give me just a couple moments. Oh, we got the fast boat coming in pretty dang fast. Wow. Bear with me just for a moment.
And we're back. I'm back.
Oops. Let me get you back on stream. There we go. You're back.
Yay.
The fast boat just like blew by the capsule. It was flying. It was
Well,
like...
yeah, generally what I've seen in other operations, the first fast boat in is to get the parachutes, to make sure they've got to pull them out of the way. They sometimes will sink, sometimes they float, so they have to deal with them.
You're looking at the Orion
the rest of the
spacecraft.
team can get in there to do any of the operational, post-landing operations.
Sorry, just had some conflicting audio on the stream, but we should be good now.
Okay. USS Portland. That was close. Colorado, Portland, you know.
USS
Not
Portland.
west. It's somewhere west of here. So big news here in Houston, it stopped raining.
Oh, nice.
So, yeah, sun came out just about the time it landed. So, excuse me, I'm having a little applesauce.
No worries at all. I'm trying to get better.
And we have our first helicopter coming in.
Yep. Coming out. I'm starting to get a hang of OBS a little bit more and starting to use the the features to like kind of update what's happening on stream separately from what's actually being pushed out to production, which is pretty cool. It's a pretty cool tool, I'm not gonna lie. Helicopter looks like it's checking things out, making sure it's safe for recovery teams, most likely.
Yep. I got to get a little shout out to Nathan Price and the North Houston Space Society yesterday. I went and gave his little speech to him, and they were nice enough to gift me a Firefly mug,
Nice.
which is too cool. One of my favorite small launchers. I'm counting on these people succeeding. We need to get something to inspire them to bring back Firefly somehow.
Yeah. Replay. All right, I'm queuing up some replays here. Looks like a big boat coming into focus here. Okay, let's zoom back a little bit.
So I mentioned Rob Navius, the voice of NASA for so many years. My older brother just tuned in and says, Rob Navius is still at NASA TV? Yes, he will never leave. It's like we got some video from, looks like an onboard camera again for a second there. And there's a recovery vehicle, USS Portland, which is where my brother lives, of course.
In Portland?
Yeah, actually, Beaverton. So yeah, I mentioned Astro Axis is in town this week to fly their zero-G flights out of Ellington Field on Wednesday, and they're collecting up, and I've been doing some, they call ground logistics, which is technically the guy who goes and buys the snacks. And I went and had to buy 700 pounds of water.
Wow.
Yeah, there's quite a bit. My poor car didn't know what to do with itself. Anyway, so I'm helping support that. But Astro Access is actually a very worthy organization, what they're doing, flying people with handicaps and so forth. And they actually have two levels. They have ambassadors, which are people there to help the physically handicapped folks with their flights. You know, basically anything needs to be done. And I'm looking forward to getting more involved with them. You'll
Awesome.
start hearing more about that in Inspire 24 also, and Space Plus too. So.
That's really nice, yeah. Yeah, they've done some zero-G flights and stuff. That's amazing.
In fact, if you want to queue up that video, the zero-G video, that's the promotional video from it. One of the things we did on that flight is Space Plus also brought along some artists, as I said earlier, and they created art. Well, then that art was then put into an auction last week, and all the proceeds went to Astro Access.
Awesome.
And I was lucky enough to put together a little syndicate, and we're able to acquire a couple pieces for our enjoyment. Actually, there's not only they created NFTs out of them, and also you get the physical artwork, which is the double bonus.
That's really cool.
So it was great to fly watching those people create and then get to see their work set out to the world to enjoy. And we've talked about the Jiramoon. They're technically sending artists also. I mean, musicians, multi-talent, multifaceted artists, and so forth. So art seems to be the big medium of the story. So yeah, this is a promotional video that and in there you get to see me playing with the zero-G because I was lucky they let me run even more lucky that I still fit in it from the mid-90s, which was a real challenge. But we get to see the zero-G puppies flying around. And you can see everybody flow. Yeah.
There you are.
It is an experience I can't promote enough. I tell people if you get a chance to do it, I know Dr. Proctor, Dr. Cyan Proctor from the Inspiration 4 mission has started, has several foundations, and she's helping fund kids to go to space camp. And also, I think she's going to be funding some zero-G flights for
so
folks
cool.
for STEM work and so forth. Yeah, I love those puppies. Love that zero-G. I have to admit, I'm addicted. I'm looking for any reason to get on a zero-G plane again.
I cannot wait to do my first one someday.
Yeah, words escape me, but I have to learn to use the words. You can, some of the video, you can see some of the guys on the side of the plane were hurriedly painting and so forth. What they did was they did some prep art. They did some black and white drawings, and then they taped them up to the side of the plane. And then we went through zero-G. They try to do art and so forth. And there was a photographer, Raven, who is one of his pieces we were able to pick up. And then Dr. Proctor, Dr. Cyan Proctor, was with us on the flight, and she did a really interesting, and I'm so amazed that she thought about this. She wanted to see how zero-G would, or microgravity would affect physical art mediums, paint, like small spheres, all kinds of stuff. So she had these, essentially they were pencil boxes, plastic pencil boxes, and she had 2 sets of them, and she prepared them almost identically she'd preload the paint and put the things in it. And the idea was one of them they would just put on and strap into a seat, and it would not be affected anyway, and it would ride the parabolas like that. And the other one she took out and she shook up and she spun it around in zero-G to see what it was. And when we saw the stuff come back, a lot of just about everything that was in the one strapped in the seat, the placebo, I guess you call it. It was basically the paint, the adhesion, and the surface tension had kept everything there, so nothing moved. But when she opened up the ones that she was able to find, there was this elaborate, multiple colors. It was psychedelic. Wow. It was amazing. The one piece of art we got from her was called Space Disco. Okay. And it was perfectly named. And it's just amazing to see those people to create that kind of art in zero-G. They're actually, since then, we've been hearing a lot of other people want to go do that again. They want to take and just have an entire flight of nothing but artists, which would be fantastic for that kind of thing.
That would be so cool. I would love to see that. Yeah, I'd like to see like a little mini documentary about some artists that go up there and do stuff like that. That would be really cool.
I think they're working on one. We shot a lot of footage.
Nice.
So they may have something, but let's see what they're talking about.
Looks like the crews are approaching the vehicle. We've got a couple more fast boats coming in. We got some smoke on the left-hand side of the screen. I'm trying to see, is that where the actual capsule is, or is the capsule kind of front and center?
I think the capsule's more the center. That smoke may be there to help indicate wind direction, because what they'll do is the capsule will stay put and the ship is going to maneuver around. Makes sense. So that its stern is in a position where they can get a line to it and pull it in. So they may need that smoke to give them an idea about the wind direction, because they're dealing with wind drift and so forth.
Yep, that makes a lot of sense, actually. Wow. It looks like there's at least 3, maybe 4 boats out there, a couple helicopters in the air. Very cool. So if anybody's just joining us, we just saw what looked to be a successful splashdown of the Orion spacecraft to end the Artemis 1 mission. It happened about 12:40 Eastern time. Crews are just approaching the vehicle now to kind of, I guess, safe it and then eventually get it onto the recovery vessel. Which reminds me, actually, I need to push out. I have another stream that's going to be going live today, and I'm going to push it out a little bit further so it doesn't conflict with this one.
Which stream? What are you covering on that?
It's kind of a secret. So it has to do with Starbase. So I have the stream up on my stream. So like you can click on it and it'll tell you when it's going to start and everything. And it just says Starbase.
Okay.
And it's going to be interesting. It's we'll see how it goes. It was more of kind of a fun project for me, and we'll see if anybody likes to watch it. But it's going to be a 24/7 feed. I'll have it going for at least a couple weeks, and we'll see how it goes, and we'll go from there. But
Okay, cool.
I had a ton of fun making it, and it's gonna be something that I'm gonna keep working on over the next couple weeks. So anybody who's
very good.
interested in Starbase, stay tuned on that.
Yeah, I'll look forward to watching that. It's always, once again, another time. It's great to be alive. You can hit the YouTubes and basically check in anywhere that we're building rockets or flying rockets and see what's going on. It's almost information overload. I think I even made a mention of it a couple weeks ago. So I couldn't find. It was during the a couple days into the Artemis mission, and there was something else going on, and I was putting up multiple windows trying to watch everything, and that's actually when I realized I need a couple more monitors so I can watch all this stuff. You've got, I think it was a SpaceX launch, there was an Artemis press conference, and there was something else going on I was trying to watch also. I think there may have been a conference or something I was trying to watch. But thank God for streaming. You can pause things. Yeah. I enjoy drinking out of the fire hose of space.
Yes, absolutely. There was a obviously we don't know exactly when Starship will launch, but there was a month or two there where it was almost looking like SLS and Starship could be like scheduled for the same week. Now, Starship might not go for a couple weeks or a couple months or who knows how long. Yeah. But it was kind of looking like everything was gonna literally happen during the same week, which would be insane because it's been decades since we've had a rocket of these magnitudes. And the fact that they would launch on the same week or something, or even close, is just absolutely insane.
Absolutely. I was holding my breath there for a little while because actually I had made a small bet that it would be Super Heavy and Starship launching first, and I'm glad I lost that bet. There was a feeling from a lot of people who weren't familiar enough with space or the history of space that NASA really could do nothing right. Look at all these problems. Oh, they can't even deal with hydrogen. Well, if you ever dealt with hydrogen is tough to work with.
Yep.
And they obviously found the correction. That's not they didn't have the technology figured out. But yeah, it was real neck and neck there, and I'm like, God, I'm gonna lose this bet.
Yep. Yeah.
But I'm happy to lose that bet.
At Rocket Ranch, they had a Rocket Ranch is so I live down here near Starbase, and Rocket Ranch is kind of it's a campground and a little kind of a little community that's grown around Starbase. And they had a big whiteboard up in their ranch building, and one side was SLS, one side was Starship, and you would write your name under which one would go first. And it was really cool to see all like the Starbase creators and stuff try to decide which one might go first. I bet on SLS, so I pulled out with
good
that
call.
one, so.
Well, to be honest, SLS had a real good head start. They've been working on it for about 20 years now. So.
Yep. Yeah, it's crazy. So it's a little hard to see here based on how far this video feed is, but the capsule is the thing between the boat and the helicopters, like that's right in the middle. It looks like a funny shape from this angle because it is the capsule, and then there's these inflatable balls on the top of it. But that is the capsule right there. And it looks like the ship is really swaying in the sea, having a hard time keeping it straight here, but the crews do look like they're getting closer. So we got. Go ahead.
I think I may have won my bet on that they're using Starlink because I haven't seen a video drop out.
True. Yeah.
Yeah, that was a standard broadcast. Unless they have a gyro stabilized dish, you would have lost with this kind of sway. You would have lost the video a long time ago.
Yeah.
In fact, I need to not look at it for a minute because I'm getting a little woozy.
Yeah, it's kind of getting crazy, but we're continuing to get some live shots in mission control, which I'm assuming that everybody's feeling real good in mission control yet, but they're not going to be able to. Oh, did you still hear me?
Yeah.
Okay.
Yeah.
I got a moment there that looked like we might have had a quick blip, but I think we're back up and running. So
yeah.
Let me check just to make sure the stream looks like it's still going, but I think we're good.
Okay.
But yeah, I think everybody will be able to kind of, have a sigh of relief when this capsule's on board the recovery ship. And
absolutely,
we are still live. So whatever, it was just a quick blip. We can bring in some of the audio here.
they added a lot of tests, and lo and behold, we're going to be up to our ears in data.
We're hearing
thankfully.
that they added a lot more tests, like we were saying earlier. The mission was going so successful, they added more tests just to make themselves even more sure that this thing is ready to go when we put crew on it.
Can skip off the
Yeah.
atmosphere.
That one thing about NASA is they're very good about planning. I mean, that's what going to space is 90% planning.
Right.
And so when you've got putting in a mission like this, people put together their primary list of requirements and a secondary and a third and a fourth, and they make lists all day long because they never know what the opportunity is going to have. And in the world of engineering and aerospace, data is king. The more data you get, the better you are. You know what's going on. That's one of those things about like SpaceX with the reusability of the Falcon 9. They have so much data on there on those rockets. When they start showing it off to the customers and the engineers talk to the engineers, they go, wow, this is amazing. You guys are showing the performance and the history of these things. That's why customers will now don't ask for new vehicles. They ask for flight proven.
Yeah, which is such a shift. It's such a shift.
Yeah, exactly.
I'll tell you from me personally, I'd rather fly on a Falcon 9 that's flown 3 times than a brand new one for sure.
Oh yeah, obviously, because if you've got all that data, and like I said, data is king when it comes to that kind of thing. Yeah, I could, if I remember correctly, they had a couple of launches recently where they expended the boosters because the client asked for the additional performance, and if I believe they used 2 of the oldest ones, the 2 that had done 14 missions.
Yeah,
which I'm like, oh man, those guys. We still have a couple more. There's 2 more at 14. I think there's a couple at 10. But to see those 2 go, it's like, like seeing an old friend, waving goodbye to him, and sending him off to Valhalla.
Yeah.
That's too bad.
I had a crazy moment actually recently for when we were one of the launch attempts for Artemis. I think it was one of the attempts that Artemis didn't launch. But anyway, we were down in Port Canaveral and we noticed there was a Falcon 9. They're always moving Falcon 9s from their ships onto the port, and they get them back in for refurbishment and all that good stuff. So there was a Falcon 9 standing on one of the ships in the Port Canaveral. And I was like, oh, this is cool. I always love seeing one of these. I've seen them a few more times or whatever. But the last time I had seen one there was when Inspiration 4 launched and it came back and the booster was in the port. Like the day after, I checked to see what this other booster was during the Artemis attempt, and it was the Inspiration 4 booster. It just had completed another mission, and I was like, oh, well, I guess welcome back, Inspiration 4 mission boosters. So it was cool.
Welcoming an old friend.
Yep.
You were out on the boat with us when we went out the morning of the launch, weren't you?
Yeah. That was amazing.
Yeah, I showed the presentation I did yesterday for the North Houston Space Society. I showed him the pictures and then the video, and then guy had a question. Says, "Did the shore patrol come after you or Coast Guard?" I said, "No, we trusted the local captain we hired to take us out there, and he didn't disappoint. I mean, I was surprised that we got as close as we did. To be totally honest, considering the no-go zones. But since it was so early and we were about 12 hours to launch, so there was no big deal. But then, and that's just one of those things. It's like, wow, we really got that close.
Yeah,
amazing.
It was amazing.
Yeah.
I was able to do that for Artemis as well, which was great.
Yeah, I believe that didn't Zach do something like that? Some of our friends, I think it was Zach and a few others, did that thing too. Yep. I just didn't have the opportunity to get that far.
Yeah.
To be there in time.
Yeah. No, it was cool. It was nice. It was cool to see SLS up close and personal before launch. Although when we did the boat trip on the first launch attempt, so it was like another month before it actually launched. But yeah, we still saw it.
Well, it's still close. We have other members of our I-24 team that work for NASA down there, and they've gotten pretty close, both in the VAB and out at the launch pad. So they get the best views. It said NASA badge, man. When I had a NASA badge, I could go anywhere I wanted. It was cool.
Yeah, must be awesome.
Well, not anywhere I wanted, but in the cool places,
Yep.
I even was able to use my NASA badge at the at Khrunichev in Moscow one time. They were going there for International Space Station construction, and they were like you show us your credentials, and I didn't have anything else from NASA. And they go, oh, NASA, yeah, you get to go in.
Wow. Wow. Oh, that must be amazing.
Yeah.
I'm going to tune in here a little bit and see if there's any sort of timelines. Let's see what they're saying.
Right. We just had splashdown and want to ask you, first of all, operationally, where do we stand and what do we have to go?
So we had a picture-perfect splashdown, and at this time we're gathering data. With the CM powered up, we'll get some flight test objective data on thermal conditioning.
Oh, there's a good shot of it.
Doing some signal data with
Look at the waves.
Oh, yeah.
Making sure that we can see
they're getting pretty
the
good
beacons
swells
on the capsules and on the astronaut suits to prepare for Artemis
So
2.
it looks like they're maneuvering, starting to try to maneuver the USS Portland closer.
Mm-hmm. Wow.
Pacific.
I'm waiting to see it. The wave hit the capsule here and see it rise up. There it is.
Right, because you will be attaching lines, and through the use of Navy boats and then also a winch inside the well deck, and Navy sailors on the lines attached to it as well. It seems like a very delicate operation, especially getting in the well deck where waves will be sloshing around, and we've got already 4 to 5 foot seas out here in the Pacific.
Correct. So it is a delicate balance to try to control the capsule and the well deck with all the water that we have in there.
I don't know. I say we hang out just for a little bit longer here on commentary, and then if they don't make like a ton of progress in the next 15 minutes, maybe we'll drop off comms and just let the stream take over.
I'm sorry, I lost my my AirPods. Decided to shut down for a moment there. Can you hear me? Okay.
Can hear you. No worries at all.
Okay, cool. Yeah, you
can
kind of
hear
went. I heard this clunk, 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 and a cartoony sound. I got some backups around here, but I have to dig them out. So
yeah.
But everything stopped here.
Yeah, I was just saying how if they don't make a ton of progress in the next 15 minutes or so, we can drop off comms in a little bit and just let the stream take over from there.
Let the stream go on. Yeah.
Yep. So it's 1:10 now. Well, what time zone is that? Yeah, 1:10 Eastern time. We'll reevaluate in 10 minutes and make a decision.
Yep. I get this impression. It looks like the helicopter's doing something around the capsule. I wonder if they're using it to tow it, maybe, but I don't see any tow lines.
Yeah, I don't know. I assume that there's like tons of like check marks they gotta actually complete prior to actually going to get it. So I'm sure it's all safety stuff.
Yeah.
As mentioned earlier, it will take about 2 hours from the time of splashdown
until
the time that
they're going to take their time on this.
And his team of
I would doubt they would take this down when they're manned. Crewed.
Ground
I got to learn the modern lingo. Crewed, when there's a crew aboard.
Of the USS Portland.
Yeah, I don't know. With that update that we just got, that it's going to take a little bit. Should we do a quick sign off on comms and
sure,
we'll
sign off and just let the stream roll on.
Yeah. So for anybody watching, we're gonna kind of do an outro here, but don't go anywhere. This stream will still stay live. You'll get the audio from the stream. You'll get all the live views and everything. Will be there for you, so you don't have to go anywhere. But thanks everybody for joining us here for this stream. What we saw today was Orion completing its Artemis 1 mission going to the moon and back, and landing what seems to be successfully down in the ocean just outside of Baja California. Teams are going to go pick it up, put it on a ship, and process it and check all the data and stuff. The thing I'm most excited for is all the video that's on board that they're going to get off of that and send it out to people. So I'll make sure I keep everybody up to date with that. I will I'll do a final outro, but before I do that, I just want to thank you again, Andrew, aka Titan, for coming on the stream again today. I always have such an amazing time when we have these conversations on here. And if you'd like to give an outro for yourself too, and let people know where they can find you.
Absolutely. Thank you very much for having me. I really enjoy this conversations we have. I love and enjoy very much sharing my enthusiasm and space knowledge with everyone. My Twitter handle is at @aparris, APARRISX, and my Instagram is AOParis, AOPARRISX. Also, if you're interested in joining the I-24, the Inspired 24, that's www.theinspired24.com.
Very good. Thank you so much.
Thank you, sir.
And thanks, yeah, for everybody that has joined or chatted or just hung out and watched the stream. Thank you, everybody, so much. My name is Andrew. This is Rocket Future. Stick around for the rest of the stream, and then check out the Starbase stream that is going to be going live in a couple hours. But for now, that's all. Andrew, I'll drop this this meeting when we end, and then that way, you know, I don't know if you want to like have a quick chat after just to debrief.
Sure.
But
yep.
I'll just call you directly on that.
Okay.
Cool. Awesome. Like I said, don't go anywhere, guys. This stream is staying up. It's just we're going to drop off commentary for now. If anything super exciting happens, I'll come back on comms. But for now, that's it for us. Thank you so much, and we'll see you next time.
Thanks, guys.
Obviously, the launch, the team has worked so hard to get to the point where we successfully launched this rocket. I think the successful burns along the way to actually get that go for the TLI burn and do it and be on our way to the moon again. Absolutely awesome. I think the pictures that we saw, but the splashdown, how can you not? I mean, this was really emotional going around and congratulating folks for what we did. So it's hard to pick just one. I think what has meant the most to me, more than just watching the mission, more than the mission highlights, is being with the teams at the Kennedy Space Center, at the Marshall Space Flight Center, here at the Johnson Space Center, and just being able to go up and talk to them and thank them for all their hard work that got us to where we are. I think it means a lot to me.
And Bob, final question. The next step, Artemis 2, putting a crew on a vehicle to orbit the moon. It's going to be a complicated mission. It's a long road. It seems like a long time from now, but based on what we've just witnessed and based on what we believe will be the ultimate data flow out of this mission, doesn't seem that far away, does it?
It is not that far away. It's going to mean a lot when we get the crew assigned. And we see them in training. We get that human face to this. I've seen the flight hardware at KSC. The Orion 2 spacecraft for Artemis 2 is there. It's in build. We got to get Artemis 1 back and transfer some of the black boxes to make sure that they get checked out and everything works. You know, the rockets being built, we are on the way. And I think when you put a human face to that, when you actually see that, hey, we're sending humans to the moon again, and we're going to get this one-year cadence eventually where we're doing this on an annual basis, this is our future, and it's different from how we went during Apollo. We're going in a sustainable way. We're paving the way to go onto Mars, not just the moon and Mars, but to establish a presence in our solar system beyond our home planet, to explore, to have those technologies in space, to continue to learn and improve things here on planet Earth.
Bob Cabana, NASA's Associate Administrator. Thanks so much for being with us, Bob.
Rob, it is always a pleasure to share a mic with the voice of NASA. I think a lot of you, buddy, you know that. We've worked together a long time. You keep doing a great job.
Thank you very much, Bob. Bob Cabana, NASA's Associate Administrator, with us here in Mission Control. This is Mission Control Houston. About 37 minutes since Orion Splashdown in the Pacific. On the deck of the USS Portland, as he has been throughout the course of the morning, Darrell Nail, my colleague from the Kennedy Space Center. Darrell, how are things going out there? It looks like you're about to approach the vehicle.
Yeah, we're very close to that moment, Rob, here on the USS Portland. We're just about 100 miles off the coast of Baja, Mexico. The operation, as you've heard and been commentating, it is going pretty smoothly at this point. But we are in a pre-planned waiting period as we wait for the ammonia that is inside the capsule. It is used for cooling. This is boiling off at this moment into the atmosphere, and until that's complete, the boats will be on hold. Now, the Navy divers right now at this moment are outside of the 120-yard radius around the capsule. That was part of the plan. They will close within just a few feet to start detecting if there are any hazardous gases coming from the capsule. But that will only happen once our recovery director, Melissa Jones, has given them the go to close in. The ship, meanwhile, the USS Portland, is on its way to close within 2,000 yards of the capsule. As you can see it floating there, the bags fully inflated that are used to upright it, bright orange in color at the top of the capsule. The ship will then come alongside the capsule, and once the Navy divers have gone in and made sure that the capsule is safe to approach, they will begin taking imagery, photographs, both on the top side of the water, and then also they have Navy divers prepared to go underneath the capsule and take pictures of the heat shield, the all-important component of this capsule, which is the primary objective in terms of the test and this flight test, is to make sure that that heat shield works and works well. So fresh from space, they want to make sure that they have images of it preserved as it is now before the operation begins, where they pull it into the well deck of the USS Portland. That will involve the attachment of ropes, as well as a winch line that then connects to the USS Portland. The well deck of the USS Portland will be flooded to about 6 feet, and those Navy boats will attach their lines and then pull alongside the Navy vessel, connect to a winch line, and then carefully tow it into the well deck. Again, we are currently awaiting the completion of ammonia boil-off from the capsule. They've allowed for up to 2 hours, but it could take a shorter period of time. And once you see those Navy boats closing in, then you'll know that that ammonia boil-off is complete. Of course, we'll let you know when that happens. Live on the deck of the USS Portland, Rob, we'll send it back to you.
Thank you, Daryl. Daryl Nail on the USS Portland out in the Pacific, west of Baja, California. Back here in Mission Control as the flight controllers watch over the initial phase of the recovery operations. We're joined by the director of the Johnson Space Center, Vanessa Weich. Vanessa, great Sunday to have you here with us on console.
Fabulous Sunday. What a great day. You know, it's amazing to me everything that has been accomplished throughout this entire mission. But being here with the team and seeing and witnessing this splashdown together, amazing, wonderful. I really can't describe how I feel.
You know, we were talking just a moment ago, it never ceases to amaze me how these missions are designed. The execution is one thing, but the design of the mission here by the flight control team, and just down the hall, by the way, there are humans orbiting the Earth and the International Space Station, so it's almost like a 2-for-1 here.
It is. I mean, you know, to me this week, and well, for the past 26 days, being able to come into the control center and know that we had teams controlling the International Space Station with our crew members on board, and we've had, as you know, successfully crews living off of this planet for over 22 years, but then in another control center where we're monitoring and making sure that the maneuvers, everything that had to happen on the Orion spacecraft, that was being tracked, followed, and, data, anything that needed to be sent up was just done so perfectly and professionally. This team has trained for years. First, you got to plan the mission, as you know. Then you have to execute the mission. And so the years of planning, the years of getting ready, the preparations really paid off.
After a team wins the World Series like the Astros did, you can celebrate for about 24 hours before you have to worry about spring training that's coming up. There's almost never a moment to breathe. Artemis 2, not too far down the pike.
Yes, absolutely. So for us, this is great. We've accomplished Orion 1, this test flight, being able to test out the heat shields, those parachutes, as you saw, brought the spacecraft down. But now we have to get it ready for our crews to be on board. So all of the systems that we need to integrate for our environmental controls, those are things that will be new as we go forward for Artemis 2. And then it's the outfitting of the cabin. All the things, simple things you think about, if they're going to be going for 10 days. So we got to make sure that we have the food, we have the clothing, all of the things that they're going to need for their next trip. But there's a lot of additional training, there's a lot of additional planning that has to happen in order for us to be ready for Artemis 2.
Thank you so much. Vanessa Weich, the director of the Johnson Space Center. What a busy time this has been.
Oh, but I also, Rob, though, I want to say thank you and congratulations to all of the employees, our entire workforce here at NASA Johnson Space Center. But I also want to thank our European partners. I want to thank our industry partners. It took thousands of people to make this possible. And now the recovery that's being done by the Navy, just want to say major thank you to the brave individuals that are out, and they're going to be bringing the Orion spacecraft into the Portland, and then she'll be back going to Florida, and my friends in Florida are ready to receive her. We're super excited and just want to say thank you to everyone that has made this possible.
Thank you so much, Vanessa Weich, director of the Johnson Space Center. Time to celebrate just a little bit before we catch our breath and press on.
Yes, time to celebrate. Then we got to get ready for Artemis 2.
Vanessa Weich, thank you so much. Back here in Mission Control, it has now been 46 minutes since the splashdown of the Orion spacecraft to complete its 25-and-a-half-day mission. Flight controllers here in Houston are reporting that the vehicle looks great. In the initial visual inspections being made by the helicopter teams, as you heard Daryl Nail reference just a short time ago, we just heard from Vanessa Weich, the Johnson Space Center director. Now let's turn our attention to the East Coast, to the Kennedy Space Center, where the director of the Kennedy Space Center, Janet Petro, is standing by with us. Janet, good afternoon, and what a moment as your exploration ground systems folks are hard at work out in the Pacific.
Absolutely. Thanks, Rob. It's been a really, really exciting morning, and can't wait for our teams to get to work out there on the West Coast.
You know, we heard a short time ago from Melissa Jones from the deck of the USS Portland. How complicated has been the development of this recovery operation that your team is executing as we speak?
Well, it's pretty complicated, but you know, our teams make it look easy. I will start out by saying, or giving, I should say, a big shout out to really Vanessa and her flight ops team and the whole Orion team to deliver an amazing mission, bringing us down through splashdown. But now it's over to Melissa and her team, and she's done an incredible amount of work to get to this point. You know, what we do at NASA, it really is all about collaborations, and the collaborations that we've had with the Department of Defense in particular over the past many years, their hard work and their dedication as they went through a great deal of planning, hardware development and processes, and a lot of practicing to get to this point and make it look easy. You know, that capsule sitting out there on the ocean, it looks very similar to the Apollo capsule, but it's actually about 30% larger. And so the complexity of recovering that larger vehicle is a little bit more. But Melissa and her team have been practicing, you know, their latest underway recovery test. They completed, it was the 9th one, and they completed that last November 21st of last year, 2021. So they're ready. Watching these teams precisely perform these recovery operations is amazing, and so I think we're going to have a really great day. I'm going to be traveling to San Diego to watch the ship come in port in a couple days, so I look forward to seeing that capsule on board the well-deck ship.
Janet, there's a lot of work to be done before Artemis 2, but the first milestone here will be getting the vehicle back to your center in Florida for a detailed inspection and detailed analysis. What's the basic timeline for all of that work?
Yeah, so Splashdown today is really the beginning of the journey back to KSC. So as I mentioned, I'll be there in San Diego when the ship comes into port in a couple of days. And then Orion will then be loaded onto a truck and transported back to the Kennedy Space Center. And that's going to take a couple of days because of road-related conditions. You know, the Orion will still have some residual hazardous waste on it. And of course, planning the roadways as it gets trucked back to the Kennedy Space Center takes some careful navigation. So by the end of this month, the end of December, we expect to have Orion coming back onto our center. We think that's going to be a really great Christmas present for us here at the Kennedy Space Center. And it'll go right into our multi-payload processing facility for its post-flight assessment. And that's where the remaining residual hazardous fluids will be removed from it. And then just after the new year, the teams will be opening up the hatch of the Orion, and then once that's complete, I think Rob, you called it the moment of truth. They'll remove that heat shield and begin a really detailed inspection and assessment of how that heat shield performed during its reentry and recovery operation. So we're really looking forward. I know the whole team's really looking forward to see how that assessment comes out. And then after that, it's Orion's journey is not done. It'll be making its way up to the Glenn Research Center, where it will be doing some acoustic and further environmental testing up at that center. So journey isn't over. It's just kind of making its way here on the terrestrial path back. So thanks.
Janet Petro, the director of the Kennedy Space Center, joining us here today. Congratulations, Janet, and thanks so much for being with us.
Thank you, Rob. It's a great capstone to our 60th diamond anniversary to have splashdown, successful splashdown. So take care. Thanks, Rob.
Thank you again, Janet Petro, the director of the Kennedy Space Center, joining us today. Orion safely upright in stable 1 as the Navy and Exploration Ground Systems team continue to approach the vehicle in the first of a multi-hour choreography that will bring the vehicle into the well deck of the USS Portland. On the deck of the USS Portland right now is Darrell Nail, who has NASA astronaut Shannon Walker with him once again, post-splashdown this time. Daryl, how are things going out there?
Rob, we've got a front row seat to this operation. As you can see behind me, Shannon Walker, as you mentioned, NASA astronaut, joining me with this incredible view as we watch that capsule floating in the Pacific Ocean just 100 miles off of Baja, Mexico. We have an MH-60 Nighthawk helicopter encircling it and the Navy boats in the water. First of all, Shannon, how about this view?
It is an amazing view and so exciting to see the Orion capsule back on Earth.
That is a human-rated capsule that went around the moon and returned and is now in the Pacific Ocean. As an astronaut, what kind of thoughts do you have seeing a moment like this?
Well, it's actually really emotional to see something like this, knowing that the next time we're going to have people on that capsule or the second Orion capsule. It's pretty amazing that we're going to be able to go back to the moon soon.
Incredible indeed. And as we look at, let's paint the picture for the audience as we look out at this operation. Currently in a moment where we are pausing for ammonia boil-off. That's the cooling that the Orion crew module uses to keep the astronauts cool inside the cabin as they wait to be taken out of the capsule. There's none in this one, but this would be a period in which that would happen. You can see the Navy boats. They are roughly outside of 120 yards from the capsule. They have equipment that will sniff out any hazardous gases near the Orion, and so they are holding in position until that ammonia boil-off happens. And then also in your view, you can see the MH-60 circling back around. It is leaning so the photographers inside and a high-resolution camera mounted on the side can get imagery of the capsule fresh from space. And my question to you, Shannon, is as we watch this continue to wait and for the Navy divers to get closer, thoughts of Artemis 2 now come to mind. You've heard folks have been talking about it. Rob has been discussing it with many of the leadership around NASA. People want to know, well, who are the astronauts going to be for Astronaut 2?
Yeah.
So, any idea?
That is the question. No, I have no idea. Once we get this capsule back, we'll look it over and we'll be able to determine when Artemis 2 will actually be able to launch. And once we know that launch date, we'll figure out the right time to name the crew based on the training flow.
So there's actually a period of training in which you have to do a set amount of time to get ready for that, but really predicated on Artemis 2 and that launch date?
Absolutely. We don't want to have the crew just spinning their wheels if Artemis 2 is going to be a long way out, but I don't think it will be, so I would say sometime in the next 6 months maybe. Is it just a guess? Don't hold me to it. We might be naming the crew.
All right, very good. Shannon Walker, NASA astronaut, thanks for joining us today. One quick update and note, the recovery team was looking at the possibility of recovering the parachutes as well as the forward bay cover, but that is not going to happen this time. They did mark their locations, but they did slip below the surface of the ocean, and so no recovery of the parachutes or the forward bay cover. That's it from right here on the USS Portland. Rob, we'll send it back to you.
Daryl Nail on the deck of the USS Portland with NASA astronaut Shannon Walker. It's been almost an hour since Orion Splashdown. Everything with the entry and splashdown went by the book. If you weren't with us for the final minutes of Orion's descent toward the Pacific Ocean, we have a replay after the deployment of the three main chutes, which were pulled out in sequential fashion after pilot parachutes and drogue chutes were deployed. The main chutes came out. They reefed in perfect fashion. Slowly descending towards the splashdown that was marked at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, at a point about 5 nautical miles or so from the USS Portland, west of Baja, California. Orion entered the Earth's atmosphere traveling 25 times the speed of sound. It decelerated to a splashdown velocity of just under 100 miles an hour. It was a very gentle splashdown for Orion. All of its entry milestones were performed in perfect fashion. 2 blackout periods in which the plasma around Orion built up, preventing data and communications with the spacecraft as a natural function of the heat of reentry, which was about 5,000 degrees Fahrenheit, twice as much as re-entering space shuttles and other crewed vehicles have experienced. But although some analysis must be performed now, and there's the splashdown itself as it occurred, analysis, as you'll hear in a moment from our next guest, must be conducted to make sure that everything went as had been prescribed on the heat shield particularly, and there's a live view of Orion as the Navy boats with the Navy divers and other recovery personnel begin to approach the spacecraft. With us here in Mission Control is Michelle Zahner, the Orion Mission Planning Lead from the Vehicle Integration Office. Michelle, thank you for joining us today. And I guess the natural and the big question is, unbelievable that all this just ticked off in trip hammer fashion the way it was designed.
Yes, it was an incredible mission. So we accomplished all of our major mission objectives. The vehicle performed every bit as well as we hoped, and even better in a lot of ways. So as an example, the solar rays generated more power throughout the flight than we expected. So this is the furthest any human-rated spacecraft has ever gone, and that required a lot of complex analysis and mission planning and trajectory planning ahead of the mission, and to see it all come together and have such a successful test mission was amazing.
Michelle, it was a test flight, of course. There was a lot of risk involved, an elevated risk because there was no crew on board, and you could take, shouldn't say liberties, but you could expand the envelope of what you needed to do in order to acquire the data that you were looking for in order to set the stage for the next mission when a crew will be on board. From a vehicle standpoint, sitting in these mission management teams, sitting with your engineers on a day-to-day basis, how much data did you acquire, and how long do you think it's going to take to pore over this so you write the textbook of Artemis 1?
Yeah, we acquired a ton of data during the mission. So one of the first things that we'll do post-mission is take several months to go back through that data, really dissect it and understand the vehicle performance. You know, we did a lot of testing and analysis prior to the mission, but nothing really compares to seeing the vehicle perform in the harsh space environment. So that's certainly going to be our first focus after the mission is looking at all that data. And as you mentioned, you know, we pushed the vehicle further than we probably would with crew on board, but through that, we learned a lot. We learned that the vehicle is more robust than we thought in many areas, and so taking that information and expanding our operational envelope will help as we go forward to more complex missions in the future.
And in the Orion Vehicle Integration Office, for yourself and your colleagues, it's almost like wearing two hats. You have to go back and pore over the data from this flight, but now you got to prepare a vehicle that will sustain a crew, including an environmental control system, a life support system for the crew itself. How are you all going to juggle all of this work over the next couple of years?
Yeah, there is a lot of work that goes on in parallel. So as I mentioned, I think the post-flight review is going to be the top priority for the first few months. But at the same time, the crew module and the European service module for Artemis 2 is already at Kennedy Space Center. It's already being put through the paces in testing. So that vehicle is already there. After splashdown here, there are some avionics that we're going to take off of the Artemis 1 crew module, refurbish, and then install in the Artemis 2 crew module. And then, as you mentioned, we have the new environmental control and life support systems and a lot of other crew interfaces like crew displays, and all of that is in the process of being integrated and tested. So we celebrate Artemis 1 today, but tomorrow we get back to work and we start focusing heavily on Artemis 2 and making sure we have a successful first crewed mission.
You're going to have to delay those vacation plans just a little bit. Michelle Zahner from the Orion Vehicle Integration Office, thank you so much for joining us today.
Thank you for having me. Appreciate it.
Back here in Mission Control, about an hour and 2 minutes now since the splashdown of Orion. Just about 5 nautical miles away from the USS Portland, which is approaching the vehicle, as well as Navy recovery teams. Back on the USS Portland, Daryl Nail from the Kennedy Space Center with the Exploration Ground Systems folks is with Captain John Ryan, the commanding officer of the vessel. Daryl?
Thanks, Rob, and Captain John Ryan here. Thanks for making the time to come and join us from off the bridge.
Absolutely.
Appreciate you being here. So far, this has been pretty amazing in terms of the completion of the mission. From your vantage point, how did you see it, and what are you seeing now?
Right now we have the orbital is in the water. Right now we're kind of in that 2 to 3 hour window where NASA and the Navy's EOD teams are conducting some tests. We're getting imagery and data for NASA, which will help support the future astronaut missions. And from perspective, honestly, I think this is one of the coolest things I've ever gotten to do. I've been in the Navy 23 years. I've done a lot of missions and I've been all over the world, but to be part of this NASA mission today is probably one of the coolest things I've ever been part of.
That's impressive, and that says a lot. As we look just behind us, Captain Ryan, and we see the operation currently in a moment of pause where they're waiting for the capsule to vent off the rest of its ammonia using its cooling system. We can see the Navy boats in the water. Currently, you've got the ship on a course heading going around this operation. What has been your instruction to your team commanding the ship?
So I just basically wanted to keep the ship within visual distance of the orbital and our teams in case they need anything. It also is providing, let's be honest, a lot of people are out here and they're super excited about this. Let's provide visual opportunities for people to get photos and, you know, get their digital part of being the history of this event. So, you know, we've a lot of time and effort and training and years of work went into this. So I want everybody to kind of get their moment, and we're out here getting ready to, you know, we'll be landing the helicopter soon and, you know, just being a part of it.
Certainly watching the sailors as it splashed down, they seem to really enjoy the completion of the splashdown part of the mission. You can see they're all smiles, cameras, and so that was good. You provided us with a perfect view of the rest of the operation. I want to talk a little bit about your ship, the USS Portland, and why it was chosen for this particular mission, and what strengths does it bring to this operation?
So the USS Portland is one of the newest of the San Antonio class LPDs. So
an LPD?
Landing platform docking ship. So this type of ship, normally known as an amphibious ship, in most of our missions we'd be working with the Marine Corps to embark their equipment and deliver them to foreign shores. But the capabilities of our ship can also be used obviously for missions like this. We have an enormous flight deck with an aviation department that we can land multiple various types of aircraft. We can put obviously a number of small boats in the water, and then probably the special feature which NASA really likes is we have a well deck which we can later flood, and we will bring the orbital into the well deck to transport it back to San Diego.
Those are some great assets that you bring to the operation, and I also know on the next one, in Artemis 2, it'll be a critical component. The medical facilities that you have on board here, you could take care of somebody with any number of injuries, and in fact, I believe even have surgery if you need it.
Yes, we have a tremendous medical capability on board. Hopefully not that it will be needed, but we do have a operating room, medical staff, and a lot of ability to take care of personnel should anything you know, not work out as designed.
This ship was just recently in Los Angeles at Fleet Week earlier this year.
Yes.
Got to show it off to the public, and that's a matter of pride, I imagine, for the team.
Absolutely. The ship has had a very busy year. The ship had returned from an overseas deployment much earlier in the year, supported Los Angeles Fleet Week and also the Rim of the Pacific exercise this summer, which had about 20 nations participating. So it's been a very busy year for the ship, and I think this is really just kind of the cherry on top where you get to do an unusual mission and support history.
Tell me about the footprint that NASA takes up on this boat. I'm sure I haven't seen all of it. I've seen a lot of it, the well deck, certainly the equipment that we have running on the various decks outside and inside, it's pretty sizable.
Yes, this is a very good sized ship. We have plenty of room. NASA has about 150 engineers and various entities on board, which we have plenty of room for. This ship would normally deploy with upwards of 600 Marines on board, so NASA's footprint really isn't too bad. It's well within our capabilities.
Well, there's been plenty of room, and you've been a tremendous host to us, and so thank you, Captain John Ryan, for having us and for successfully bringing us to this part and this moment of the operation.
It's been an honor to support the NASA engineers and to be out there and be part of this.
Thank you very much. Thank you. Captain John Ryan, the commanding officer of the USS Portland. And as we push out our view here in the Pacific Ocean, just 100 miles off the Baja Peninsula, you can see Orion now as a silhouette, still floating, the Orion Command Module with its CMIS bags. Those are the uprighting bags, fully deployed. It's in a stable condition. And to the right of that, you see the first Navy boat. That's a rigid hull boat. That one is the one that's going to get a little closer and provide a stabilizing tow line once it's been determined that the Navy boats can get a little closer. As we pan just to the right of that, you will see the remaining 4 boats. 2 of those boats are inflatable boats with Navy sailors aboard. Those Navy sailors will put hands on the capsule and secure it with ropes. They will then maneuver to bring that capsule to the rear of the USS Portland. The Portland will then throw out a more than 1,000-foot rope and then several 400-foot ropes. And that long rope will then attach to the capsule. It'll connect up and then begin pulling the Orion in. Now, this is a very complex operation. Think about this. That capsule does not have a keel, so it's a smooth bottom, 16.5 feet in diameter. So when it is pulled, it doesn't track in the water very well. So what has to happen is there are ropes attached to 4 points around the capsule that help stabilize it. Navy sailors, a team on each of the 4 ropes, and then on a 5th rope will be the winch. And that winch will apply enough pressure required, enough pulling force to bring that capsule into the well deck of the ship. At the moment, as we've been telling you, we are currently standing by awaiting ammonia boil-off. This is the coolant that's provided on the Orion capsule. It keeps the astronauts, should there, once they eventually go into the capsule and go on missions to the moon. Currently, no astronauts in this capsule, but we've got to vent off the ammonia nonetheless. The allotted time for that is 2 hours. And so we are just 1 hour and 10 minutes into that waiting period. And then once it's clear, you'll see those Navy boats get closer. But currently, we are still standing by, waiting for the completion of ammonia boil-off. That's it, live from the deck of the USS Portland. Of course, we'll have more interviews for you as we go along. But for now, send it back to Rob Navius in Houston.
Thank you, Daryl. Looks like a beautiful day out there west of Baja, California. A lot of smiles here in Mission Control in Houston. We're about 1 hour and 11 minutes since the splashdown of Orion to wrap up its 25.5-day mission. Integral into the flight of Orion was the performance of the European service module that functioned perfectly to take Orion out of Earth orbit on its way to the moon, and did everything it was asked to do throughout the course of the flight. And joining us is Philippe Delou, who's the Orion European Service Module Program Manager from the European Space Agency. Philippe, congratulations. Thank you for joining us today.
Thank you, and good afternoon.
Philippe, that service module went through its paces and was spot on every time it was asked to conduct a burn. Everything that it was planned to do was executed perfectly. Your thoughts on this mission?
Well, I have to say that I'm the happiest man in the world at the moment with the successful performance of the service module. She did what she was supposed to do, and even better. So it's a wonderful mission. I couldn't have dreamt more.
Now, the service module for the next flight, in which a crew will be on board, is at the Kennedy Space Center undergoing testing, and it's going to be a while for all of that hardware to come together, but you all are off and running on preparations for the next mission in a couple of years.
That's correct, yes. Well, we have already assembled the service module back in Europe and delivered it. Now it's being integrated with the crew module in Kennedy, and that's, if I don't mistake, should happen in the next summer.
Philippe, the work that the service module did, obviously invaluable. You can't conduct this mission without the work of the European service module. What kind of process was involved in getting to the point where the design of this mission, the requirements that the service module was asked to perform, and then ultimately conducted over the last 4 weeks? How did this evolution of this mission unfold for you and your team?
Well, this is a story that started quite a long time ago, in 2011, when there was a decision that the crew module would be built by Europe. So there's been a long process into setting up the requirements, proposing a design, discussing the design, also involving NASA, and agreeing on what should be the final design, take up the challenges which are associated with the design, eventually build the hardware, integrate it, and then preparing for the mission. So this has been a long way and a lot of work by the European Space Agency and the European industry.
And you know, down the hall where the International Space Station is controlled out of, ESA is a frequent flyer to the International Space Station, and the international partnership, of which ESA is such a critical contributor, is so valuable to human spaceflight now and in the years ahead. Talk a little bit about that.
That's clear. I mean, going to explore deep space is a challenge, is a big challenge. And we need all the excellence over the world in order to tackle that challenge and make it sustainable. Going there once, yes, is doable, but in order to go there on a regular basis and for a sustainable exploration of what is out there, first on the moon, then Mars, and then beyond, this will require all the forces and skills of the engineer around the world, and that's with ESA and NASA. We have started that process with the Artemis program.
Philippe Delou, a little moment perhaps to sample some bubbly to celebrate this moment, but a lot of hard work ahead, and thank you so much for being with us today.
You're welcome. It was my pleasure.
Philippe Delou, the European Service Module Program Manager, joining us here in Mission Control. Thank you, Philippe.
You're welcome.
This is Mission Control Houston, and all of the action now is focused on the USS Portland, west of Baja, California. My colleague Daryl Nail is there. Daryl?
Rob, thank you. Yep, we're here on the deck of the USS Portland, just 100 miles off the coast of Baja, Mexico, and I'm joined by Valerie Vinchulo. She is the General Dynamics Applied Physical Sciences Senior Engineer. Thanks for being here.
Yes, of course. Great.
So Valerie has some fresh information and analysis that she's been doing as it pertains to this operation, bringing the Orion command module into the well deck of the USS Portland. And so she has been looking at the wave heights with a system that you use, and tell me, you've just now analyzed the sea heights what kind of sea heights are we dealing with, and what does that mean for the recovery of the Orion capsule out there in the ocean right now?
Yes, so we have 2 wave monitoring systems, 2 radars on board the ship. So we're monitoring the waves, measuring the Doppler velocity of the waves in the vicinity of the ship. So from that, we're able to get the significant wave height and where the direction of the waves are coming from along with the period. So right now we're seeing about 4 to 5 feet of waves at about 13 seconds from north-northwest. So with that information, we're able to provide a recovery heading for the ship that'll optimize, minimizing the motion in the well deck. So we're really trying to minimize that sloshing and bore wave in the well deck.
And that's a key point right there, Valerie. Of course, as I don't know if you could tell at home, but we're on the ship deck leaning back and forth to those 4 to 5 foot waves that we're dealing with out there in the ocean right now. So imagine Orion bobbing out there in the ocean, coming into a well deck where those waves come into the well deck. So what has been your recommendation to the team about how to deal with these waves as they bring that capsule close?
Right, so right now we're recommending a recovery course of 320 to kind of mitigate that motion. So we're kind of looking at the roll of the ship to minimize that sloshing wave, and the course of 320 is looking like the best for that recovery. That will give us a little bit of a bore wave that we're going to experience, but it's something that we think we can deal with, and we're looking forward to the recovery.
This is important because, of course, inside the well deck, I've heard it explained that once those waves come in, and then the ship, as it's moving about, creates a big wave pool inside.
Yes, yeah.
That's not good for a spacecraft that you're trying to stabilize.
No, you don't. You really want to minimize those motions to the best of our ability, and in doing so, we're just looking at everything out there, all the waves, what we're dealing with, and we have hydrodynamic ship models of the ship and of the well deck. So we're running through all of our models live, taking the live radar data, and just trying to provide the best information available here.
And so when they have that information, what is your role after you've given it? Do you continue to monitor? Are you active?
Yes, we're constantly monitoring and running the system. We're always recording data to analyze later, so constantly doing that. And we'll provide little tweaks and updates, as we get closer. But once they've started flooding, we're really on that course. So we'll just keep monitoring what's going on.
Those 2 radars on the ship, where are they located and what frequency are they using?
So they're located on the 05, and it's an X-band radar, and over here on the 04, so we have 2, and that gives us, putting them both together, gives us a full 360 degrees, which is what you want. You want to be able to see all the waves around the ship, and they're actually an X-band radar that's been vertically polarized, so we can see the Doppler velocity as it's coming in to calculate that wave height and the swells and the wind waves in the direction they're coming in.
That's high-tech stuff. I mean, it's, you've got Doppler radar. Many people may be familiar with how that helps with weather, telling our audience and weather people where the weather is, where the storm clouds are, but it literally can map out in 3 dimensions the waves around the ship.
Yes, yeah, so we're looking, a lot of X-band radars, they're looking for targets, right? Another ship, avoidance, but we've polarized our radars to try to look at the waves, and just what other people might consider noise is what we want to capture. So.
That's interesting. It's just the opposite of what it's typically used for.
Yep.
Well, Valerie, last question I want to ask you. You've been on the ship since we departed San Diego on Wednesday.
Yes.
It's been a long journey to get to this point, this weather alternate spot where the seas are much lower. They're now 12 feet or so off of San Diego, so this is certainly something you probably appreciate.
Yes, yes.
But let me ask you about that operation and looking out there and seeing that space capsule in the water. What was like that for you watching?
Oh my gosh, it was amazing. It's something I will probably remember the rest of my life. Hearing that sonic boom and then seeing the chutes, oh my gosh, it was incredible.
Valerie Chulo, thank you so much for joining us.
Yeah, thank you for having me here.
All right, Rob, we'll send it back to you.
Thanks, Daryl. The work continues out in the Pacific, where you have the Orion spacecraft with all 5 of its uprighting system bags fully inflated, following its splashdown 1 hour 21 minutes ago at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, to wrap up a mission of 1.4 million miles that spanned 25.5 days, a mission that saw the vehicle launch from the Kennedy Space Center atop the Space Launch System, the maiden flight of the world's most powerful rocket. An hour and a half after launch, Orion was sent out of Earth orbit in its translunar injection to begin a voyage out to what is called a distant retrograde orbit, a highly elliptical racetrack-shaped orbit that enabled Orion to be put through its paces for almost a month, gathering all the data that it needed and that the Orion program and mission managers had hoped for, and more. All of the engineering data that will set the tone and answer a lot of the questions that will pave the way for the Artemis II mission, in which a crew will be placed on board the vehicle in a couple of years for a orbital mission around the moon, again in a highly elliptical orbit, a mission that would be about 10 days in length or so. That crew yet to be named, but the pace will pick up after the first of the year in fairly dramatic fashion as the work continues to prepare the Space Launch System, the next Space Launch System rocket, and the Artemis II Orion vehicle to support a crew during its mission around the moon and back to Earth. In the meantime, a number of test objectives are still underway for the vehicle, most notably characterizing the thermal environment of the Orion spacecraft itself. Orion endured temperatures of up to 5,000 degrees Fahrenheit during its high-speed entry out of lunar orbit and back into the Earth's atmosphere, where it slammed into the atmosphere at 25 times the speed of sound, and then underwent a skip entry maneuver, basically skipping into the atmosphere, then dipping back out of the atmosphere again, and then back into the atmosphere to bleed off excess energy. An important maneuver that was designed and executed to perfection to bleed off excess inertia and to gain data on how we can better bring in multiple splashdown sites if required in the Pacific for future crewed missions. All of the chutes were deployed in good shape. The three main chutes deployed as planned. They reefed to their full extent, and Orion gently splashed down. After entering the Earth's atmosphere at 25 times the speed of sound, it splashed down at a meager velocity of just 19 miles an hour. Very gentle splashdown velocity had a crew been on board. And here's a replay of the final seconds for Orion as it descended below a deck of clouds at about 1,700 feet of scattered clouds. That was the final deck. The Spaceflight Meteorology Group had forecast very benign conditions for Orion. It did play out exactly that way as Orion touched down at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time. And there was splashdown. The chutes were cut automatically. The 5 crew module uprighting system inflatable bags inflated with helium gas as planned, and Orion is gently bobbing out with the Navy divers very, very close to the spacecraft. It's going to take several hours for them to hook up the equipment that they need to haul the vehicle into the well deck of the USS Portland and to bring it back to port. Back here in Mission Control, the entry team of flight controllers watching the data of the post-splashdown test objectives, in which data is being acquired on the thermal characteristics of Orion. There'll be a restart of the ammonia boiler system to gain data on long range and extra cooling for the vehicle that will be in the offing when a crew gets on board. We'll be talking more about the crew aspect of what lies ahead a couple of years from now, a short time from now. But now it is time to go back to what is a very busy place on the USS Portland, and my colleague Daryl Nail. Daryl?
Thanks, Rob. Yep, I'm here with Cody Kelly, who is the National Affairs Manager in the Search and Rescue Office at NASA. In terms of your job, we had good visual today of the capsule coming down. We clearly have the visual right now. We can see it in the water.
Yes, sir.
We know where it is. But that might not always be the case. The capsule may be beyond our visual sight, as well as in Artemis 2, the astronauts. Tell me about what your role is and how you help find out where they are in a situation like that.
Yes, sir. My name again, Mike Cody Kelly. I work in our SAR mission office. Basically, we work with all of our federal and international partners to ensure that our spacecraft are interoperable with the Search and Rescue Satellite Aided Tracking System, or the SARSAT system. So today for Artemis 1, we tested out the vehicle tri-band beacon, which was using swept tones for the helicopters that are flying around behind us to be able to locate that spacecraft in kind of what we call the terminal area, which is within about 1 nautical mile where you can get visuals, as well as the 406 megahertz beacons that were on the capsule, as well as what the astronauts are going to wear in Artemis 2. We were using what's called the SAR Intelligent Terminal, or the SAINT application, which is a system that ties into our ground station at the Goddard Space Flight Center to pull in all of the data from these beacons so that we can see them anywhere in the world. And that's incredibly important, especially when we have crewed missions where we, if we had some kind of emergency abort or some kind of landing, we'd have to be able to get data to our DoD partners extremely fast, even if they're landing internationally. And this is something that we do for all of our human spaceflight programs. But Artemis really has a kind of special place in my heart because all of this effort started way back in 2016 with URT-5. So we actually demonstrated some of our advanced technologies on URT-5 and slowly was able to be integrated with the landing and recovery team to provide them that key data on the day of landing and if there was any kind of emergency. The astronauts are going to wear what's called the Angel beacons, which are the advanced next generation emergency locator beacons that are located on their life preserver equipment, and that's going to be able to track an astronaut if they had to get out of the capsule, if there was an ammonia leak or some kind of emergency, as well as tying that into what the vehicle telemetry is saying to be able to give a good SAR picture to these guys that are flying helicopters looking for survivors or being able to go rescue astronauts.
And so let's talk a little bit about that further. The astronauts will be wearing GPS, essentially they're GPS locators, right?
Exactly, yes, sir.
They're beacons. And then, of course, the crew module itself has a tri-beacon.
Yes, sir.
So how do you delineate between those two?
And that's really the power of our ground station and all these web applications. They're two different legacy beacons. You have a first-generation SARSAT beacon, which is what you have on a standard boat. Even the ship itself has a first-generation beacon. And then we have what is called a second-generation beacon, which is an advanced waveform that's specifically for the astronauts themselves. In our application, we're able to actually identify each of those beacon IDs and tie them to a specific crew member so that when they turn it on, we know exactly whose beacon that is and exactly where it's at. And the power behind that is with these emerging technologies, we're able to do this even if we have bad GPS connection or we're really anywhere in the world. And this is the kind of stuff that you can have is if you go to a vendor and buy it for your boat. If you're out hiking, we're using those technologies for civilians for astronaut use and kind of vetting it out here out in the open ocean, knowing that astronauts are really one of our prime customers.
So you ran a test today, right?
Yes.
As this operation was unfolding, the crew module was sending out its beacon, its tri-beacon, but then you also had those Angel beacons for the astronauts. They were what? You put them on the boats,
yeah,
right?
we put them on the ribs or the rigid hulls inflatable boats that are out there tending the capsule, as well as on the fan tail of the ship. What we're doing is we're looking to make sure the air crews could delineate between these various beacons if the crew members ever had to get out, as well as looking at the performance of the vehicle tri-band beacon after it's spent almost 2 weeks in space. So we're looking at not only today's technology but tomorrow's technology to kind of serve Artemis emerging partners and really the folks that are going to be in harm's way on a daily basis.
Your test was part of the operation today, and how did it perform?
It went phenomenally. I can't give more kudos to the crew of the Portland, First Air Force Deck. Set 3, setting that all up with the Navy, the Air Force, as well as some of our national partners in the U.S. StarSat program that made this all happen. So it was really a team effort, and it went flawlessly, just like this mission. So I couldn't be more happy.
And you could clearly identify the capsule and the 2 Angel beacons. I mean, it was clear as day.
It was clear as day, and we've been working on this application for over 2 years with this mission in mind, and it executed flawlessly. And the coders and developers at Goddard Space Flight Center did a phenomenal job being able to get this ready on time, on mission, and on location.
Cody Kelly, Manager of National Affairs, Search and Rescue Office at NASA. Thank you very much for joining us.
Thank you.
Rob, we'll send it back to you.
Thanks, Daryl. Great job out there, by the way, throughout the course of the day. A great view of Orion as it sits passively in the fairly calm waters of the Pacific, west of Baja, California. With me here, sitting very calmly, veteran astronaut Randy Bresnik. Randy, thanks for joining us today. You have been an integral part of the preparation of not only this mission, but all of the astronaut office activities associated with requirements that will ultimately lead to putting a crew on the next vehicle that will orbit the moon in 2 years. What did you see today that A, thrilled you, and B, was most important for you to see as a result of all the work that has gone in to make this mission possible?
That is a great question, Rob, and thanks for letting me come join you guys this morning. Certainly watching the team throughout the past 26 days was certainly the culmination of seeing that and walking in here and see this team be able to see the fruits of their labors. Seeing that we have a launch platform that was nearly flawless, practically flawless, you know, getting our Orion uphill, and then having our service module, you know, give us power and the flight control and the burns that all went off so well with so small residuals that we hardly had to do any trimming. And it was then great to see all the cameras that we put on that vehicle to bring everybody along on the mission. And, you know, put selfie as a word that we use now in spaceflight, you know, and Artemis 1 getting the selfies while we were up there. And then certainly everyone holding their breath as we did the burns to get into the distant retrograde orbit and then get out of the distant retrograde orbit and then be able to make the trim burns to be able to get right, hit entry interface as accurately as we did here. You know, see the service module separate, which is another big milestone, and then see the last, you know, few minutes of flight with Orion flying on its own for the very first time. And then see how well it controlled itself and how the forward big cover came off on time, the drogues came out, slowed it down, mains came out, and we landed, you know, 2.5 miles from the, you know, pinpoint bullseye, and we had expected maybe, you know, 5.5 miles. So it was awesome to see all of that, and that whole collection is what gives us confidence for the next time. You know, all of these things that were individually areas of concern have now been proven in flight.
You know, we've talked often during the course of the broadcast today about the fact that this is the 50th anniversary of Apollo 17's landing on the moon. Gene Cernan, Jack Schmitt, past his prologue, as they say. And now, from an astronaut office perspective, as you look down the road over the next 2 years, a lot of work to do, but certainly a leg up on what we think will be a launch in the 2024 timeframe.
Absolutely. The, you know, post-flight data reduction and everything else will be amazing to see in the next few weeks and months. But starting next week, we're right into Artemis 2 continuum processing. We got Artemis 2 crew module and service module sitting there at KSC right now, going through its final, you know, their final assembly. And then we have to do the verification, validation, test out, and make sure everything's working. And things like systems like the ECLIS system, which we didn't have on this. And so the first time that we're flying with that system will be when crew are on board. And so that'll be a, you know, really important, thorough checkout here on the deck. Certainly, you know, in the next quarter, ideally assigning the crew to it so that we can start building their spacesuits, getting them involved in training, and getting them ready to go in that 2-year mark. And hopefully we will either meet or beat that 2-year mark. And so that'll be exciting to see if we can move that fast and continue the momentum that we got from this flight.
And an interesting flight design for Artemis 2, where another highly elliptical orbit around the moon. This is not like your father's Apollo 8, where we simply orbited almost at an equatorial nature, but we're going to be chasing the interim cryogenic propulsion stage as well.
Yeah, certainly. when you look at how bold Apollo was, we had never been to the moon. We didn't know we could do it. We planned on having Apollo 7, and we flew that crew module in low Earth orbit. And then Apollo 8, we launched it around the moon, and it stunned the world, and proved to ourselves, that we could do this. Well, guess what? We're doing that in one mission on Artemis 2. We're doing Apollo 7 and 8 combined. So that is a bold statement and audacious goal for NASA to set. And like you said, the highly elliptical orbit that we launch of in here on Earth, so we can launch out, get into a 24-hour orbit to check out that environmental and life control system, such that we know that we can breathe. We know that the cooling works. We know that all the systems work. Scrub the CO2, take out the humidity, to try the exercise device. So we know that by the time we end that period and we do the translunar injection burn, we know that we're good to go for the next 9 days to be able to get around the moon and come on back. All of that just buying down risk, proving out the systems, so that when we go to Artemis 3, we combine not only Apollo 9, which is the first flight of the LEM in low Earth orbit, Apollo 10, which took the LEM to lunar orbit and flew down near to the surface, then came back, and Apollo 11 landing. We do all those 3 of those missions in one. And that is very exciting, very bold, and it has got to be exciting to anybody that's in the space program, is interested in the space program, or the young people out there who are the first future space explorers who will be on those later Artemis missions.
Final question, Randy. Space is no stranger to you. You've spent quite a bit of time, shuttle flight, long-duration mission on the International Space Station. But if there was a singular image from the last 25 and a half days that sticks with you, that drove it home, that we were going well beyond the Earth, what would that be?
It would certainly be the missions where we were on the far part, where we were 268,000 miles away from Earth, and you saw Earthrise over the moon, and thinking that the next time we take those pictures, that could be with somebody behind the back of the camera, not the vehicle taking it himself.
It's going to be an interesting couple of years, a very exciting couple of years, and Randy Bresnik, thanks for joining us today. Appreciate it.
All right, thank you, and congratulations to our Artemis team everywhere all over the world. They deserve a very well-deserved day off after this mission, but certainly looking forward to the next 2 years where we are able to take that and capitalize on it, and, as we say, wash, rinse, repeat.
Copy that. Thank you, Randy. Appreciate it. Randy Bresnik with us here in Mission Control. It's been about an hour and 40 minutes since Orion Splashdown. We're continuing out in the Pacific to secure the spacecraft and ultimately get it into the well deck of the USS Portland. As the team here in Mission Control works through the post-splashdown procedures before they hand the vehicle over to the Exploration Ground Systems recovery team on the USS Portland. Again, let's go back out west of here to west of Baja, California, where Daryl Nail is standing by on the deck of the USS Portland. Daryl?
And it's simply beautiful out here, Rob, and we've got a perfect view, a front row seat to the Orion Splashdown. I want to give you a quick update on the recovery operations. Recovery Director Melissa Jones has decided to go the full 2-hour waiting period for ammonia boil-off, and so that's going to put us at 11:40 a.m. Pacific time for the boats to then close in and get next to the spacecraft and begin sniffing it for any hazardous gases. You can see it just right off the port side of the USS Portland, still in the water. The Navy boats off to the left, they're standing by for that moment, which is in just about 18 minutes from now. They're going to go in and start that procedure. Both helicopters, though, are back on the flight deck as well. Those assets have completed their part of the job. I want to bring in now Jeremy Vanderkam. This is a special individual. Well, of course, everybody's special, but when it comes to the heat shield, this is something you know well. You are the Deputy Thermal Protection System Manager for the Orion program. Your team designed the heat shield, tested it, and have been basically there from the start of this. And so I want to ask you, this, of course, has been the primary objective of this test flight. That's right. Testing the very component, the heat shield, that you and your team helped design. And so I want to ask you, first of all, how much do you just want to get out there and take a look at that heat shield, which is right behind you?
I can't wait. Yeah. I tried to convince lots of people to let me in the small boats. Didn't happen, but that's okay. We'll be doing our inspections once we get hard down in the well deck later this afternoon, and we'll get a good look at how we did.
Do you have any early information from the imagery that has been taken thus far?
Not a lot so far. We've been, looking at the capsule as it floats in the water through our binoculars and whatnot. Everything looks great, exactly as we expected it so far. But yeah, we'll get the details going here in a few hours.
So tell me about this particular heat shield. It is different and also similar in ways to previous heat shields. Tell me about it. How does it work?
Yeah, so this is the largest ablative heat shield that humans have ever devised for a spacecraft devised to take humans farther away from our home planet than ever. So what we did is we combined some older technology. We actually resurrected a material system from the Apollo program called AVCOAT, and we modified the way that it's applied to our vehicle for Orion in a more programmatically modern way, if you will. So the way that we do it now is
you got a piece of
I have a sample here, a test sample. So the brown material in the middle here is our AVCOAT material, and we make it in blocks, and we bond those blocks to the base of the Orion spacecraft onto the heat shield there.
It looks like wood.
Yeah, it does. It does look like wood. It's not. I can assure you. Yeah. And then there are seams between those blocks, which is the red element that you see here. And in this test sample, we've actually applied heat in our test facilities at Ames Research Center in Mountain View, California, to simulate the heat of reentry, to char the surface just as it is on the base of the spacecraft right now. And then what we'll do is when we get the spacecraft back in, we'll go and look at how that heat shield works compared to our test results. And that'll allow us to certify then the heat shield for Artemis 2.
You've done a lot of testing on this heat shield, but you were telling me that no matter how much you test it, you can't duplicate what it just went through.
That's correct. Yeah, what I'm holding here is about the largest size thing that we can test. And obviously the 5-meter Orion heat shield is much larger, so we have a lot of extrapolation for scale that we have to do. And similarly, our test facilities can't reach the combination of heat flux, pressure, shear stresses, etc. that an actual entering spacecraft does. So we're always having to wait for that flight test to get the final certification that our system is good to go.
So I'll trade you props here and let you hold the actual Orion. And tell me, you said you've used binoculars, you've sighted the spacecraft. One side of it, I guess, gets a little more charred than the other. What have you seen?
Yeah, so far it's actually looking like we expected. The inward side is the hot side of the vehicle. And so we can see that, for example, the thermal control tape that we put on the exterior of the vehicle, all that shininess that we saw pre-launch, is basically gone on the windward side, as expected. And then on the leeward side, where the windows are, I'm seeing a fair amount of tape remaining, as expected. So our heating predictions, how that the heat contours over the vehicle were predicted to be, looks like that's how they were. So, so far, so good.
Jeremy Vanderkam, thank you so much for joining us. He is the Deputy Thermal Protection System Manager for the Orion program, and I know you're anxious to get that capsule in this well deck so you can get your eyes on it.
Yep, I'm ready.
Good luck the rest of the way, Jeremy.
All right, thank you.
All right, we'll send it back to you, Rob.
Thank you, Daryl. Back here in Mission Control. We're about 32 minutes or so away from the point at which the entry team of flight controllers plan to hand the vehicle over to the Exploration Ground Systems recovery team that Daryl has been involved with on the USS Portland. That will come after the completion of detailed flight test objectives, the last of which will be the restart of an ammonia boiler system to provide additional cooling for the vehicle. This is a test to see what kind of additional cooling might be required once a crewed mission returns from the moon to maintain the most comfortable level of cooling for a crew on board that is returning from the moon for an extended period of time, particularly if they wind up splashing down a further distance away from the recovery ship than Orion did today. Everything went perfectly during Orion's high-speed entry back into the Earth's atmosphere, and its splashdown and all of the post-splashdown activities that have occurred so far as we We'll be continuing our coverage until Judd Freeling, the entry flight director, hands back the vehicle to the Exploration Ground Systems folks out in the Pacific. And again, back here in Mission Control, you're looking at Flight Director Judd Freeling. In the middle of your screen, to his left, Flight Director Rick Henfling, as the entry team of flight controllers heading into the home stretch of their work here before they hand the vehicle back to the Exploration Ground Systems folks on the deck of the USS Portland, where, again, my colleague Daryl Nail is standing by with yet another guest.
Thank you, Rob. And as you can see behind us, still right here on the port side, we have Orion floating, stable, and the Navy boats there tending the ship. And we should be sending them in, and in just about 10 minutes from now, they will begin sniffing for any hazardous gases that will be coming off, and then they'll secure Orion. In the meantime, we have Dr. Emily Spreen, the Sasquatch team lead for NASA, and if you thought that your name was unique, well, it is. It surprised me when I was on the ship walking by your door and I saw Sasquatch team. I thought, what might that be? And then I found out, and it's fascinating. Emily, tell me, first of all, what is the Sasquatch team? What do you do?
So Sasquatch is in charge of generating waypoints for the ship and for the small boats, as well as creating footprints, which is where we get our name Sasquatch. So Sasquatch generates big footprints, and those footprints contain the debris field as it's coming down. And that's used to help position the helos in the air and keep people safe and outside of that debris field as we are, having a spacecraft splash down.
Absolutely, and it's really incredible. You were explaining to me, how you calculate these footprints, and just for background, as the Orion comes down and separates out the forward bay cover, which reveals the parachutes, and then there are certain items around that, a sabot, a lid, various pieces are coming out of it, and your team is able to model exactly or approximately where those pieces fall in the water so that assets can get close. How do you figure that out?
So a lot of the data came out of CPAS drop test, that's Capsule Parachute Assembly System drop test. Those are done out in Yuma. That was used to prove the Orion parachute system. From that, we were able to derive a lot of the aerodynamic properties of some of the debris objects, which I've got some here.
Sure do.
So these are drogue, lid, and sabot. They're not flight versions, but they are, representative size. These would be, on top and bottom of a parachute as it's mortar deployed, like a cannon out from Orion. We've also got a smaller piece of debris here, and that's a pilot sabot. So essentially, at the drop tests, we were able to, really hammer down what those different aerodynamic properties are using rate of descent and then where those things touch down in Yuma. And we're able to use that in our model here for actual Artemis 1 operations.
And as I understand it, there are 26 pieces of debris, right, that came out from, the separation of the forward bay cover and the parachutes, and you model every single one of those 26 pieces?
Their model is a group, so, we've got a group of lids, that come off at drogue parachute deployment, right? So we've got, a couple lids that come off, a couple sabots. And so we say, the lids and sabots, they'll be in this footprint as that footprint descends and then goes into the ocean.
And as it lands into the ocean, I guess the shape that it kind of takes is that Sasquatch, a giant foot.
That's right, a footprint.
With all that debris coming down, I mean, the different aerodynamic properties, this is going to be different than, say, the larger one, which is going to be different from the parachute. what kind of modeling goes in to be able to tell where that parachute's going to float? Because a parachute takes many forms as it's falling.
Right. So we're taking in, we're using that CPAS data, but we're also taking in day of weather conditions. So we've got, weather people on board the USS Portland with us, and we're talking with Spaceflight meteorology back in Mission Control in Houston, and we're getting information that we're using to take into account, because once things are on parachutes, just like you said, they're drifting. But with that, we were able to predict the CM splashdown location within a nautical mile. So
that's impressive.
Yeah, we're really, really pleased. It went beautifully.
Wow, nice job to your team and to you.
Thank you.
That right there is impressive. I was just going to ask you, how about the rest of the debris field? Were you able to determine with what level of accuracy the rest of it came down?
So right now, none of those other pieces have GPS information on them. We're hoping to get some information about that later. We'll see what the ship's capabilities are and what NASA's able to get from that. But that's something that's still in the works, so we'll see.
All right.
I'm pretty certain.
Emily Spreen, Sasquatch team lead for NASA. Thank you to you and your team for doing such a great job with us and joining us.
It's been an honor. It's been great. Thank you.
All right. Rob?
Thanks, Daryl. We're coming up on the 2-hour mark since Orion Splashdown on target in the Pacific, west of Baja, California. The end to Orion's 25-and-a-half-day mission culminated a mission that was punctuated by a tremendous number of highlights, and we can take a look back at some of those highlights now. That began with the launch of the Space Launch System from Launch Pad 39B at the Kennedy Space Center at 1:47 a.m. Eastern Time on November 16th. The Space Launch System lifted off, conducted a roll program to place itself on the proper azimuth and the proper trajectory to enter a orbit of the Earth. It would spend the Orion spacecraft itself with its associated European service module and the attached interim cryogenic propulsion stage would spend one orbit in low Earth orbit. And there is the separation of the core stage. The vehicle conducted a translunar injection burn that enabled Orion to break out of low Earth orbit and begin its trajectory toward the moon, and the elliptical orbit, the highly elliptical orbit, called the distant retrograde orbit, that provided the time that was required for Orion to acquire data on the space environment and the time required for engineers to test all of its systems and collect as much data as possible in this first test flight that would precede placing a crew on board an Orion spacecraft 2 years from now. This dramatic video of the Earth-Moon transit that took place showed and punctuated the fact that we were pressing away from our home planet to a distance of some 268,000 miles away from Earth, further than any human-rated spacecraft had ever traveled, for a spacecraft designed to return humans to Earth, eclipsing the mark set by the Apollo 13 vehicle back in 1970. The distant retrograde departure burn that began the trip home for Orion this past Monday. You can see the effect of that engine firing on the solar arrays on Orion's service module. That, in effect, was what amounted to a deorbit burn of sorts that placed Orion on a trajectory to return to Earth, which it did today with a splashdown 1 hour and 58 minutes ago. As we circled back around the moon for the return powered flyby, we saw a dramatic close-up of the moon and the crescent of the Earth in the distance, using the moon's gravitational field as a slingshot effect to set our sights on the Earth and the trajectory required to splash down in the Pacific, which we did, as Orion gently waits for the arrival of the recovery team that will begin the process of hauling the spacecraft into the well deck of the USS Portland. And this was the view from the cabin camera looking upward out of the forward bay, basically the top of Orion, as the first chutes were deployed. These were the forward bay covered parachutes that in turn pulled out drogue chutes and then the 3 main parachutes to dramatically slow down Orion's descent back to Earth. And as you see here, under 3 fully reefed chutes, Orion finally splashed down at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, to wrap up its mission of 1.4 million miles. This is Mission Control Houston. Flight controllers here reporting back to Flight Director Judd Freeling that they have begun the power down of Orion's systems, with everything looking good and data having been acquired. So the post-splashdown test objectives are nearing an end. The vehicle is being powered down, and we should be a short time away from the point at which Flight Director Judd Freeling hands over the vehicle to the Exploration Ground Systems folks out in the Pacific. We'll be heading back shortly to the USS Portland, but as you can see, the first contingent of the Navy boats are approaching the Orion spacecraft, which is in great shape following its high-speed entry and splashdown that occurred just over 2 hours ago. We're just minutes away from handing over the vehicle to the Exploration Ground Systems folks. This is Mission Control Houston. Entry Flight Director Judd Freeling, who also was the Ascent Flight Director for Orion's launch aboard the Space Launch System 25.5 days ago, is addressing his team of flight controllers here in Mission Control. With that, Judd Freeling has handed over the Orion vehicle to a round of applause. The vehicle has now been handed over to the Exploration Ground Systems folks out in the Pacific, where my colleague Daryl Nail is standing by with members of the Navy helicopter team that saw Orion up close and personal about 2 hours ago. Daryl?
That's right, Robin. They were the first to see it. They picked up the heat signature as it came above the horizon, and they were the first to have a close-up look of the Orion crew module as it was in the water. I have with me, as you mentioned, 3 Navy pilots with the HSC-23 squadron in the Navy. They were flying the MH-60s, the Nighthawk helicopters. I've got Jacob Naylor, Jackson Cotney, and Gabe Weigelt. Thank you all for being here, and it's great to have you.
Thanks for having us.
Yeah, thank you. Well, tell me, first of all, this operation, for those who were watching earlier on, we saw your helicopters going around the area almost immediately after splashdown. Tell me about how you're able to do that and then what unfolded for your mission.
Yeah, so basically we have a FLIR camera mounted on the front of the helicopter and about 7 NASA personnel in the back. So while they're riding in the back, they're giving us azimuth and elevation angles to take a look at, and basically right away, even earlier than we expected, we picked up the capsule coming in. And so us 3 were the backup aircraft pilots, but we did hear it come over the radio that they had it captured right away. They have basically a FLIR that uses infrared, so it's seeing that how hot that capsule is coming down. They caught it a whole way down, which was exactly what we needed for that engineering data.
Easy to lock in on, right? At 5,000 degrees Fahrenheit, the bottom of the heat shield. that FLIR was just almost instantaneous as soon as that thing came above the horizon. Then you began capturing imagery, and we watched as the helicopters circled, and sometimes they were doing some pretty nice banks around the Orion crew module. What was that about, Jackson? Why did they take that path around Orion?
Yeah, so the second part of the mission was to get a hazard analysis of the capsule, and then just engineering level fidelity data, like imagery from some of the photographers on board. And then we had another helicopter up that was testing out the new Angel beacon that the crews are going to wear eventually when the capsule does come down. So that all deals with our primary mission set of search and rescue, which is what we're hoping to do in Artemis 2, is to actually pull the astronauts from the capsule via the hoist.
Right. And so you guys were also using data from the Sasquatch team. We just interviewed them and heard about the great work that they did in predicting where that debris field would be coming down, 26 different pieces as the crew module was getting its parachutes out and everything. Using that data, how accurate was it for you, and how did it help you fly around the area?
So there was actually one of the NASA personnel in the back had a tablet which had the debris field on top of it, and as time goes on, that debris field could get a little smaller and smaller, and so they helped give us headings and guidances on where to turn and where to get the aircraft to avoid any of that debris field coming down and hitting us in the head on the helicopter. So
yeah, right, and successful. You guys were looked great out there at sea, surrounding the capsule, flying, in fact, at sometimes very closely. We saw you hover. I don't know what the feet was, but it looked pretty close to the ocean surface.
Probably about 50 feet above, just so that the photographers could get good data. And then we were kept safe by Emily and her team. The whole Sasquatch team helped us with the footprint so that we knew where we could fly, so that we'd be safe.
Where does this rank for you guys in terms of your mission? I mean, you're young fellas, so you don't have your call signs yet, which eventually you'll get that. But being a part of this mission, it's very different, right? The civilian nature, where most DoD missions are not of that nature. So where does it rank in terms of you? What kind of what was it like for you?
It's absolutely amazing, and certainly a career highlight for us up until this point. Yeah, we were still just in the backup aircraft, but just being able to just support these awesome pilots that were out there with us. We had Therapist and Ripper and Stapler and James. All of them did such a great job. So we're just really excited that this is both exciting for us and kind of plants that seed to be exciting for everyone else watching, and excited for the next mission with astronauts in it. So.
And that'll be the next great part, right? So as Navy pilots, you'll be able to hover over top of the next capsule that comes down, and it's going to have astronauts in it. Briefly describe what you imagine that would be like.
That's got to be an unreal experience. I hope I'm still around to be able to be a part of that, because that's got to be one of the greatest feelings ever, pulling someone out of a capsule that's just been to the moon and back. Unimaginable feeling, I got to say.
Absolutely. Well, thank you all. We appreciate you. Jacob Naylor, Jackson Cotney, and Gabe Weigelt with the HS-23 Squadron. Great job today. Thank you for joining us, and we appreciate you being here.
Thanks for having us.
Thank you so much. Appreciate you.
All right, and here on the USS Portland, the mission continues. The operation to recover the Orion command module, which you see is still out there in the Pacific. We're awaiting the Navy boats to get a little closer to begin their operations and sniffing out hazardous gases and making sure that they are able to connect up to that capsule and tow it back inside the USS Portland, our Navy ship on scene here. That's going to do it for us, for the Exploration Ground Systems, the Department of Defense, and NASA. We want to send it back to you, Rob, in Houston, Texas.
Thank you, Daryl, and magnificent job out there on the USS Portland, and the work is just beginning out there, as you heard. Here in Mission Control, the work is over for the entry team of flight controllers who have handed the vehicle over to the Exploration Ground Systems folks out in the Pacific, with the power down of Orion having been completed. Entry Flight Director Judd Freeling has released his team, and they will be making their way out of Mission Control, with Orion's handover now complete. Splashdown occurring at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time. The team is posing for a team picture before they are released for the day. Upcoming, you can follow, if you wish, all of the remaining recovery work, including the Orion being brought into the well deck of the USS Portland on the YouTube channel that you see there, www.youtube.com/KSC Newsroom. The Kennedy Space Center Exploration Ground Systems folks now in charge of the operations to bring Orion back into the well deck, to get it back on shore, and then transport it back to the Kennedy Space Center for post-flight analysis. That'll wrap up our coverage of Orion's return to Earth, and let's point you to our post-splashdown news conference that's coming up at 2:30 p.m. Central Time, 3:30 p.m. Eastern Time on NASA television, as a variety of folks discuss entry, splashdown, and recovery, and take a look back at the 25-and-a-half-day mission of Orion, its first flight, next stop, a crew on board 2 years from now. With that, we wish you a great Sunday. This is Mission Control, Houston.